If you could stand at the edge of time and look back, not at history, but at everything we've forgotten, what would you see? Not ruins, not relics, but intentions, patterns that were never random, designs that were never simple, traces of something built with a purpose we no longer understand, because some ancient remnants don't feel like the beginning of knowledge. They feel like what's left after it, like the final pages of a story whose beginning is missing. And the deeper you go, the more one idea refuses to disappear. What if the past isn't primitive at all, but the remains of something far more complete than anything we've created since? High above the plains of northern Ethiopia, carved into a vertical sandstone cliff in the mountains of Tigray, stands one of the most astonishing religious structures ever created by human hands, the church known as Abuna Yemata Church. Believed to date to roughly the 5th or 6th century CE, this church sits approximately 2,580 meters above sea level and is accessible only by climbing a sheer rock face that even modern hikers consider dangerous. Visitors must ascend a vertical wall of sandstone roughly 13 to 15 meters high, traverse narrow ledges sometimes no wider than 20 centimeters, and pass through natural crevices before reaching the entrance. Yet what awaits inside is not a crude hermit's cave or a rough sanctuary carved in desperation. Instead, the interior reveals an astonishingly refined chamber, adorned with vibrant frescoes that have survived for more than 1,500 years. The existence of this church raises multiple questions about ancient engineering, logistics, and artistic technology, questions that archaeology has only partially answered. The church itself is carved directly into the living sandstone cliff. Rather than being constructed block by block, its interior chamber was excavated out of the rock face, producing a rectangular sanctuary roughly 6 by 9 meters in size. The ceiling arches gently above the room, and several stone pillars appear to support the structure. Yet these pillars were not placed there but sculpted directly from the original rock mass. Such techniques are reminiscent of the famous rock-hewn churches of Lalibela, built several centuries later in Ethiopia. But Abuna Yemata presents an even greater technical puzzle. Lalibela's churches were carved downward from relatively accessible ground surfaces. Abuna Yemata, by contrast, was excavated in the middle of a vertical cliff, where workers had almost no stable platform from which to operate. Archaeologists studying the site have struggled to reconstruct how early builders could have transported tools, pigments, food, and water up the cliff during the excavation process. There is no clear archaeological evidence of scaffolding holes, rope anchor points, or large wooden structures that might have supported the builders. The absence of such evidence has led some researchers to suggest that construction may have relied on temporary rope systems or wooden pegs inserted into cracks in the rock, techniques known from traditional Ethiopian climbing practices, but no physical remains of these systems survive. However, the greatest mystery of Abuna Yemata lies not in its architecture, but in the extraordinary preservation of its interior artwork. The walls and ceilings of the church are covered with intricate frescoes depicting biblical figures, apostles, and saints associated with early Ethiopian Christianity. Painted in vivid reds, yellows, whites, and deep blacks, the figures appear remarkably intact despite their immense age. Many of the portraits retain sharply defined outlines and expressive facial features. Even more striking, the pigments remain bright and saturated with very little fading. Considering that these paintings may have been created as early as the 6th century, around the same time the Byzantine Empire was constructing monumental churches in Constantinople, their state of preservation is extraordinary. To understand why this is so unusual, it is useful to compare Abuna Yemata's frescoes with other ancient mural traditions. In Europe, Many medieval church frescoes dating from the same era have deteriorated severely due to moisture, smoke, and environmental exposure. Even the famous frescoes of the Sistine Chapel, painted 1,000 years later in the 16th century, required extensive restoration because centuries of candle soot and humidity darkened the pigments. Likewise, knee murals from Roman sites such as Pompeii Archaeological Park, buried under volcanic ash since 79 CE, still show visible pigment loss and surface damage despite being preserved in sealed environments. In contrast, the paintings inside Abuna Yemata appear astonishingly vibrant, as if the artists had completed them only centuries ago rather than over a millennium earlier. Several archaeological surveys conducted during the late 20th and early 21st centuries attempted to analyze the pigments used in these frescoes. Researchers studying small fragments and surface residues found evidence of mineral-based pigments typical of ancient painting traditions: iron oxides for red tones, yellow ochre derived from hydrated iron minerals, and carbon-based compounds for black outlines. These materials are not unusual. They were widely used across ancient civilizations from Egypt to Byzantium. What remains puzzling, however, is the binding medium that allowed these pigments to adhere so strongly to the sandstone walls. In classical fresco painting, pigments are applied to wet plaster so that they chemically bond with the lime as it dries. Yet inside Abuna Yemata, there is little evidence of a thick plaster layer comparable to those used in Roman or Byzantine frescoes. Some scholars suspect that the artists used a thin preparatory coating composed of clay, organic binders, or egg-based tempera, but the precise formula remains uncertain because sampling the paintings is extremely restricted in order to avoid damage. Another explanation proposed by scientists involves the unusual microclimate inside the cliff church. The sanctuary is naturally protected from rain and direct sunlight by the overhanging rock face. At the same time, the interior maintains a remarkably stable environment with relatively low humidity. Because the church sits high above the valley floor, air circulation within the chamber remains steady, preventing the buildup of moisture that would normally encourage mold growth or pigment decay. In effect, the cliff itself acts as a natural preservation chamber. Similar environmental conditions have helped preserve prehistoric cave paintings in sites like Lascaux Cave, where stable humidity and temperature allowed Paleolithic artwork to survive for more than 17,000 years. Yet even those cave paintings have required modern climate control systems to prevent deterioration once exposed to visitors. Abuna Yemata, by contrast, has maintained its artwork naturally for over 15 centuries with minimal intervention. Archaeologists who documented the frescoes in the early 2000s were particularly impressed by the stylistic coherence of the paintings. The figures are arranged in symmetrical compositions across the ceiling, forming a circular array of apostles and saints looking down toward the center of the room. The artistic style shows influences from early Byzantine Christian iconography, suggesting cultural connections between Ethiopia and the broader Christian world during the late antique period. Ethiopia had adopted Christianity as a state religion in the 4th century under the Kingdom of Aksum, making it one of the earliest Christian civilizations on Earth. Yet historical traditions describe a group known as the Nine Saints, missionaries believed to have arrived from Syria and the Eastern Mediterranean, who helped spread monasticism and theological learning throughout the region. According to local oral tradition, one of these figures, Abuna Yemata, established the cliff church that now bears his name. No written records explain how the church was built or how its frescoes were painted. Researchers still debate how artists created such detailed artwork while working hundreds of meters above the ground, carrying pigments and tools up the dangerous cliff. The frescoes remain one of the site's greatest mysteries. Scientists can identify the mineral pigments, but the techniques and binding materials that preserved their colours for 1,500 years are still unknown. The church of Abuna Yemata Gu Church therefore stands as a remarkable achievement of early Ethiopian Christianity, and leaves a lasting question. How could paintings remain so vivid after 15 centuries? What do you think allowed these ancient frescoes to remain so vibrant for more than 1,500 years on such a dangerous cliff? Share your thoughts in the comments below. The Maltese Misqa water tanks sit quietly on the rocky slopes of Wadija Ridge in northern Malta, overlooking a landscape that has struggled with water scarcity for thousands of years. At first glance, the site appears simple, a cluster of circular depressions carved directly into pale limestone bedrock. But closer inspection reveals something far more remarkable. The Misqa complex consists of a series of carefully engineered rock-cut cisterns, many measuring between 3 and 8 meters in diameter and reaching depths of 4 to 6 meters, capable of holding tens of thousands of liters of water. In an island where the average annual rainfall is only around 500 to 600 millimeters and permanent rivers do not exist, such reservoirs would have been essential for survival. Yet the true mystery of the Misqa tanks lies not merely in their size or placement, but in the sophisticated hydraulic technology implied by their construction, particularly the ancient waterproofing system that once sealed the tanks and whose composition remains uncertain even today. The tanks themselves are carved with an accuracy that suggests deliberate geometric planning. Their walls are strikingly smooth, their curves almost perfectly circular, and their bases slope gently toward collection points that maximize water retention. Archaeologists studying the site have noted that these shapes were not random cavities, but engineered basins designed to collect and store runoff water, flowing down the surrounding limestone slopes. Small channels and natural grooves in the rock appear to have directed rainfall toward the openings of the tanks. During seasonal storms, water would cascade across the hillside and funnel directly into these reservoirs, transforming the entire ridge into a catchment system. Such understanding of hydrology suggests a community that had carefully studied its environment and designed infrastructure to compensate for a naturally dry climate. Excavations and surveys carried out in the 20th century began drawing attention to the site's unusual sophistication. Early archaeological work in the 1920s and later field studies in the 1960s and 1970s documented the dimensions and layout of the cisterns, revealing that the complex was not a random collection of holes but a coordinated water storage installation. Some researchers proposed that the tanks could have been associated with nearby prehistoric settlements or agricultural zones that required reliable water supplies during dry seasons. Others suggested that they might have served communities connected to Malta's ancient temple culture, which flourished between approximately 3,600 and 2,500 before the Common Era, and produced some of the oldest freestanding stone architecture in the world. However, the absence of diagnostic artifacts within the tanks has made precise dating difficult. As a result, theories about the origin of the Misqa tanks range from the Maltese Temple period to later Phoenician, Carthaginian, or Roman agricultural activity. Regardless of their exact age, the engineering challenge posed by these cisterns would have been considerable. Malta's bedrock is primarily Globigerina limestone, a relatively soft stone when freshly cut, but one that becomes more porous as it weathers. Without some form of waterproof lining, stored water would gradually seep into the rock and be lost. This brings us to the most intriguing and unresolved aspect of the Misqa tanks: the evidence suggesting that the reservoirs were once coated with a waterproofing layer, whose exact composition remains unknown. Traces of plaster-like material have been reported in some of the cistern walls, hinting that ancient builders intentionally sealed the rock surfaces to prevent leakage. Yet the fragments that survive are too degraded for a definitive chemical reconstruction, leaving archaeologists to speculate about the technology behind it. Waterproofing technology in the ancient Mediterranean is known from several later civilizations, which makes the Misqa tanks particularly interesting for comparison. Roman engineers famously developed hydraulic concrete known as opus cementitium, a mixture of lime, volcanic ash, and aggregate capable of hardening even underwater. This material was used in massive cisterns such as the Piscina Mirabilis near Naples, built in the 1st century before the Common Era to supply water to the Roman fleet. The Piscina Mirabilis holds more than 12,000 cubic meters of water and is lined with a specialized waterproof mortar that has survived for 2 millennia. Similarly, ancient Near Eastern civilizations such as the Nabateans and Persians used gypsum-based plasters and bitumen coatings to seal reservoirs and canals in arid environments. However, Malta lacks natural sources of volcanic ash like those used in Roman concrete, raising questions about how Misqa's builders achieved similar waterproofing properties. Some archaeologists believe the lining may have been made from a lime-based plaster produced by heating limestone to create quicklime, then mixing it with sand, crushed ceramics, or ash to improve its water resistance. Others have suggested the possibility of a gypsum compound derived from evaporate minerals occasionally found in Mediterranean soils. A more speculative theory proposes the use of organic additives, such as plant resins or animal fats, that could have enhanced the impermeability of the coating. Without intact samples large enough for full laboratory analysis, however, none of these hypotheses can be confirmed. What remains clear is that the tanks were unlikely to have functioned efficiently without some deliberate sealing method. The existence of such a coating implies that the builders possessed practical chemical knowledge about materials capable of resisting water infiltration. Archaeological surveys in the late 20th and early 21st centuries attempted to document remaining plaster traces and analyze the erosion patterns inside the tanks. In several cisterns, researchers observed subtle discolorations and thin mineral layers that might represent the remnants of a once continuous lining. Yet centuries of exposure to weather, vegetation growth, and human activity have likely stripped away much of the original surface. If a waterproof coating once existed, it may have gradually dissolved or flaked away over time, leaving only faint chemical residues embedded in the stone. This erosion complicates efforts to reconstruct the original technology. In contrast, Roman cisterns often remain protected within enclosed structures, preserving their mortar coatings far better than the exposed Misqa reservoirs. The possibility that such waterproofing technology could predate Roman hydraulic engineering is what makes the Misqa tanks particularly fascinating. If the site indeed originated during Malta's prehistoric temple culture, the builders would have been developing advanced water management techniques more than a millennium before Roman hydraulic science emerged. Malta's temple builders were already capable of transporting and shaping megalithic blocks weighing several tons, constructing monuments like Gantija and Hagar Kim around 3000 before the Common Era. Integrating water infrastructure into this landscape would have required a similar level of organizational planning and environmental knowledge. Even if the tanks were constructed later during Phoenician or Roman times, the precise method used to seal the porous limestone remains an open question because no intact example of the original coating has yet been identified. Beyond the waterproofing puzzle, the broader function of the Misqa tanks continues to be debated. Some researchers believe the system supported agricultural terraces that once covered the surrounding hillsides. Others suggest that the tanks may have served as communal reservoirs for nearby settlements, ensuring reliable water during droughts. Another possibility is that the cisterns were integrated into ritual landscapes associated with Malta's prehistoric temples, where water may have held symbolic or ceremonial significance. Each theory reflects the importance of water in an island environment where fresh supplies have always been limited. Today, the Misqa water tanks remain one of Malta's lesser-known archaeological mysteries. Despite attracting little tourist attention, they may represent an important example of ancient hydraulic engineering. Their precise rock-cut geometry, strategic placement for collecting rainwater, and traces of a mysterious waterproof lining suggest that their builders possessed surprisingly advanced knowledge of water management. Until future research reveals the composition of that lost waterproof layer, the Misqa tanks will remain a quiet reminder of an ancient technology that may have been far more sophisticated than it first appears. What material do you think ancient builders used to create the waterproof lining in the Misqa water tanks? And could this technology have been more advanced than we assume today? Share your thoughts in the comments below. Hidden deep within the arid landscape of southern Israel, the copper mines of Timna Valley represent one of the most remarkable and mysterious centers of ancient metallurgy ever discovered. Located in the Negev desert roughly 30 kilometers north of the Gulf of Aqaba, this vast valley contains evidence of copper mining that stretches back more than 6,000 years, with activity beginning as early as the 5th millennium BCE and continuing through the Egyptian, Edomite, and later Roman periods. Yet what makes Timna Valley truly extraordinary is not simply its age, but the scale and sophistication of the metallurgical technology developed there. Technology that, according to many archaeologists, seems surprisingly advanced for societies that supposedly possessed only primitive tools and limited scientific knowledge. The valley first attracted major scholarly attention in the 20th century when archaeologists began systematic excavations across the desert basin. Surveys quickly revealed thousands of ancient mining shafts carved directly into the sandstone cliffs. Some shafts descend more than 30 or even 40 meters below the desert's surface, branching into narrow tunnels where ancient miners once followed thin veins of copper ore through the rock. The sheer density of these excavations suggests an enormous industrial effort. Researchers have identified more than 10,000 individual mining pits scattered across the valley floor and surrounding slopes. Even more striking are the vast black mounds of slag, waste material left behind after smelting copper, which in some areas rise several meters high. Yet estimates suggest that the total volume of slag produced at Timna reaches tens of thousands of tons, indicating that the valley functioned as a large-scale metallurgical production center rather than a simple local mine. Yet the true mystery of Timna lies not underground, but in the technology used to extract metal from ore. Copper smelting requires extremely high temperatures, often exceeding 1200 degrees Celsius, in order to separate the metal from surrounding minerals. Achieving such temperatures is difficult even with modern equipment, yet the ancient metallurgists of Timna managed to do so using only clay furnaces, charcoal fuel, and manually operated bellows. Archaeological excavations have uncovered dozens of smelting installations consisting of small, cylindrical furnaces built from heat-resistant clay and lined with carefully prepared refractory materials. Ceramic tuyères, nozzle-like pipes that directed blasts of air into the furnace, have also been discovered, demonstrating that ancient metallurgists were deliberately controlling airflow to intensify combustion. What astonishes researchers most is the gradual improvement in smelting efficiency visible in the archaeological record. Chemical analyses of slag samples conducted by researchers from Tel Aviv University and other institutions show that early smelting attempts in Timna were relatively inefficient, leaving significant quantities of copper trapped within the slag. However, over time the technology improved dramatically. In slag layers dated to around the 13th century BCE, copper extraction efficiency appears to have been only 1 to 2%. By the 10th century BCE, however, the amount of copper successfully recovered from ore had increased several times over, with some slag samples showing efficiencies approaching 8 to 10%. In practical terms, this meant that ancient smelters were extracting several times more usable metal from the same quantity of ore, a level of technological refinement that suggests systematic experimentation and technical knowledge passed down through generations of specialists. This improvement has led some archaeologists to describe the metallurgical development at Timna as a kind of ancient industrial revolution. Unlike isolated discoveries elsewhere in the ancient world, the technology here appears to have evolved rapidly within a relatively short period of time, perhaps little more than a century. Such rapid progress raises difficult questions. How did ancient metallurgists discover the precise balance between fuel, air flow, furnace design, and ore composition necessary to achieve efficient smelting? Without written scientific theory or modern measuring instruments, how were they able to consistently reach temperatures high enough to melt copper and separate it from impurities? And perhaps most puzzling of all, how was this specialized knowledge transmitted among workers in what was likely a largely oral culture? Excavations conducted in the early 2010s added another intriguing dimension to the story. Archaeologists uncovered remains of large workers' camps near the smelting areas, including textile fragments, food remains, and animal bones. Radiocarbon dating of these organic materials indicated that major smelting activity occurred around the 10th century BCE, a period traditionally associated with the biblical kingdom of King Solomon. Although the popular nickname King Solomon's Mines had long been used for the Timna copper deposits, modern archaeologists had initially dismissed the connection as legend. However, the new radiocarbon data suggested that large-scale industrial activity was indeed occurring in the region during the same historical period described in biblical narratives. Whether or not the mines were directly controlled by Solomon's kingdom remains debated, but the evidence confirms that a highly organized society capable of managing large mining operations once existed in the harsh desert environment. The sophistication of Timna's metallurgical technology becomes even more striking when compared with other ancient copper-producing regions. In many early mining cultures, such as those found in parts of Anatolia or the Balkans, smelting technology remained relatively inefficient for centuries, with large amounts of copper still trapped in slag waste. By contrast, the metallurgists of Timna appear to have gradually optimized their production methods through repeated experimentation. Furnace structures evolved to channel airflow more effectively, slag composition changed as impurities were removed more efficiently, and the overall yield of copper steadily increased. Some researchers believe that metallurgists may have deliberately adjusted furnace angles to capture prevailing desert winds, thereby increasing oxygen flow and boosting combustion temperatures without additional fuel. If true, this would suggest an empirical understanding of airflow and thermodynamics that is rarely associated with ancient desert societies. Despite decades of research, however, many aspects of the technology used at Timna remain unresolved. Archaeologists still debate the exact methods by which ancient smelters controlled furnace temperatures, as well as the precise composition of the fluxes, materials added to ore to assist in separating metal from impurities. Some slag samples contain unusual chemical signatures that suggest the deliberate mixing of different ores or minerals during the smelting process. Whether these mixtures were discovered through trial and error or represented a deeper understanding of metallurgy is still unclear. Today, the silent mining shafts and slag fields of Timna Valley remind us that ancient technological knowledge may have been far more advanced than once believed. Thousands of years before modern science, metallurgists in this desert valley built a large-scale system for extracting and refining copper. Their furnaces reached temperatures high enough to melt metal, and their techniques improved steadily over time. Yet the exact methods that allowed these early engineers to master copper production are still not fully understood. leaving Timna as one of the most intriguing technological mysteries of the ancient world. How did ancient metallurgists in the harsh Negev desert master such advanced copper smelting technology thousands of years ago? Share your thoughts in the comments below. Beneath the volcanic hills near the ancient naval harbour of Misenum, not far from modern Bacoli on the Bay of Naples, lies one of the most astonishing feats of Roman engineering ever constructed, the immense underground reservoir known as Piscina Mirabilis. Built in the late 1st century BCE during the reign of Augustus, the structure functioned as the final storage basin of the massive Aqua Augusta, a complex aqueduct system that transported water more than 100 kilometers from springs near Serino across the rugged terrain of Campania. Today, when visitors descend the stone stairway into the reservoir, the first impression is almost surreal. The interior resembles a vast underground cathedral, a forest of 48 massive pillars arranged in symmetrical rows supports a sequence of vaulted ceilings stretching across a chamber approximately 70 meters long, 25 meters wide, and nearly 15 meters high. When filled, the basin could store roughly 12,600 cubic meters of water, over 12 million liters, enough to supply the enormous Roman fleet stationed at Misenum, one of the empire's most important naval bases. The scale alone is extraordinary, but the true mystery of the structure lies not in its size, but in the material technology that made such a reservoir possible. The remarkable waterproof concrete developed by Roman engineers more than 2 millennia ago. The entire interior surface of Piscina Mirabilis was coated with a specialized hydraulic plaster known as opus signinum, a mixture composed primarily of lime mortar, crushed ceramic fragments, and volcanic sand. This coating formed a waterproof barrier that allowed the reservoir to hold millions of liters of water without significant leakage. At first glance, the idea might appear straightforward, but modern materials scientists have found that Roman hydraulic concrete behaves in ways that differ profoundly from modern cement. Studies of ancient Roman harbour structures and water systems in the Bay of Naples have revealed that the volcanic ash used in Roman concrete reacts chemically with seawater or groundwater over long periods of time, gradually forming rare mineral crystals such as tobermorit and philipsite. These minerals actually strengthen the concrete structure over centuries. In other words, rather than degrading with time, Roman hydraulic concrete can become more durable as it ages. This phenomenon has been documented in geological and engineering studies conducted by researchers from institutions including the University of Utah and Stanford University during the early 21st century, who examined samples taken from Roman maritime structures along the Campanian coast. The same volcanic materials were abundant in the region surrounding Mount Vesuvius, and it is widely believed that similar mixtures were used in the lining of Piscina Mirabilis. The result was a waterproofing system so effective that large portions of the reservoir walls remain intact more than 2,000 years after construction. What makes this particularly intriguing is the contrast with modern concrete technology. Most modern reinforced concrete structures built with Portland cement are designed to last roughly 50 to 100 years before significant degradation begins due to cracking, corrosion, or chemical weathering. Roman hydraulic concrete, by comparison, has survived for over 2 millennia in some of the most chemically aggressive environments imaginable, including saltwater harbours and underground water systems. Engineers still debate the exact ratios of ingredients used by Roman builders, because ancient texts, such as those written by Vitruvius, describe the materials only in general terms. Vitruvius noted that volcanic ash from the region around Pozzuoli possessed special hydraulic properties that allowed mortar to harden even underwater. However, he did not record precise mixing proportions or the specific preparation techniques used by Roman construction crews. As a result, Modern attempts to replicate the durability of Roman concrete have produced mixed results. The Piscina Mirabilis reservoir therefore serves as a kind of archaeological laboratory, offering a large-scale example of how this ancient material performed in a controlled hydraulic environment. Archaeological investigation of the reservoir began in earnest during the 19th century, when Italian scholars first recognized the site as the terminal storage basin of the Aqua Augusta aqueduct system. Later excavations throughout the 20th century revealed additional details about the structure's engineering design. The reservoir floor was slightly sloped to allow sediment to accumulate in specific zones where it could be periodically removed, while the thick waterproof plaster lining ensured that water stored inside would not infiltrate the surrounding volcanic rock. The pillars themselves were built from concrete cores faced with brick, another typical Roman technique that combined structural strength with ease of construction. Each pillar helped distribute the immense weight of the vaulted ceiling and the earth above it, preventing collapse while maintaining a cavernous open interior. Engineers have calculated that the total volume of masonry and concrete used in the reservoir reaches many thousands of tons, all placed with remarkable precision despite the limitations of ancient surveying technology. Yet despite decades of research, several aspects of Piscina Mirabilis remain puzzling. One question concerns the exact process by which Roman builders applied the waterproof coating so evenly across such a vast surface area. The plaster layer had to be thick enough to resist water pressure, but also flexible enough to avoid cracking as the structure expanded or contracted slightly with temperature and moisture changes. Another mystery involves the long-term chemical stability of the materials. Modern laboratory experiments suggest that the interaction between volcanic ash and lime produces a complex microstructure that evolves slowly over centuries, but the precise conditions required for this process are still not fully understood. Some scientists believe that Roman construction crews may have possessed empirical knowledge of material behavior gained through generations of experimentation, even if they lacked a theoretical explanation for why the mixtures worked so well. Comparisons with other Roman hydraulic structures further highlight the sophistication of the technology. Large reservoirs existed elsewhere in the empire, such as the massive cisterns beneath Constantinople. Yet Piscina Mirabilis stands out because of its scale, preservation, and direct association with a major aqueduct system. Unlike many cisterns that relied primarily on masonry walls, Piscina Mirabilis employed a fully integrated concrete vault system capable of supporting enormous loads while maintaining watertight integrity. Even after centuries of abandonment following the decline of the Roman fleet at Misenum in late antiquity, the reservoir structure survived largely intact. When modern archaeologists entered the site, they found that much of the waterproof lining still adhered firmly to the walls, evidence of a material technology that had endured far longer than most modern equivalents. Often called the underground cathedral of water, Piscina Mirabilis reflects the extraordinary engineering of the Romans. Using simple materials like lime, volcanic ash, and crushed pottery, they created waterproof concrete that has survived for thousands of years and built a reservoir capable of storing millions of litres of water. Even today, historians and engineers still wonder how such durable technology was achieved. After 2 millennia, the chambers of Piscina Mirabilis continue to guard that mystery. What do you think is the real secret behind the Romans' waterproof concrete? Was it simply knowledge gained through generations of experience, or did they once possess a level of engineering understanding that we still do not fully grasp today? Share your thoughts in the comments below. The Valley Temple of Khafre stands at the edge of the Giza Plateau as one of the most intriguing architectural structures associated with the pyramid complex of the 4th dynasty pharaoh Khafre, who ruled Egypt around the 26th century BCE. Unlike many other temples of ancient Egypt built primarily from limestone blocks, this structure was constructed using enormous slabs of red granite, transported from the quarries of Aswan, located nearly 800 kilometers to the south along the Nile. Archaeological excavations carried out during the 19th and early 20th centuries, most notably those directed by the German Egyptologist Ludwig Borchardt, and later studied by numerous architectural historians, revealed that the temple was not only remarkably well preserved, but also built with a level of stone precision that continues to provoke debate among engineers, archaeologists, and historians alike. Inside the temple, massive granite blocks weighing between 40 and 50 tons each form walls that appear almost seamless, their surfaces polished and fitted so tightly that in many places even a thin blade cannot be inserted between them. Granite is one of the hardest stones commonly used in ancient architecture, with a hardness approaching 7 on the Mohs scale, which means shaping it requires tools capable of exerting tremendous force and maintaining consistent precision. According to the traditional archaeological interpretation, Egyptian workers primarily used copper chisels, stone-pounding tools made of diorite, and abrasive sand to cut and shape granite. However, when modern engineers attempt to replicate the same degree of flatness and precision using only these tools, the process proves extraordinarily slow and labor-intensive, raising questions about how ancient craftsmen could have produced such vast quantities of perfectly dressed stone within the time frame of a single royal construction project. The interior of the temple further intensifies this mystery. 16 monolithic granite pillars once stood in the central hall, each carved from a single block and polished to an almost mirror-like finish. Their edges are remarkably straight, and their angles close to perfect right angles, suggesting careful measurement and advanced planning. Beneath these pillars lies a floor composed of large black basalt slabs, another extremely hard volcanic stone that would have required sophisticated cutting techniques. These basalt slabs are arranged with striking precision, forming a smooth and stable floor surface that has endured for more than 4,000 years. Archaeologists have also discovered that the outer casing of the temple was originally covered with finely polished white limestone from the quarries of Tura, creating a dramatic visual contrast with the dark granite interior. This combination of different stone types, each with very different hardness and structural properties, would have required an advanced understanding of stoneworking and architectural planning. Comparable levels of stone precision are sometimes seen in other ancient monuments, such as the carefully aligned blocks of the Great Pyramid of Giza, the polygonal masonry of Puma Punku, or the enormous megalithic stones of Baalbek Trilithon. Yet the Valley Temple is unique because it combines enormous block size with extremely tight joints and highly polished surfaces within a single structure. Despite decades of research, some of the most fascinating aspects of the temple remain unresolved. The technical mysteries surrounding its construction continue to challenge conventional explanations. One of the most debated questions concerns the cutting and shaping of granite itself. Granite is significantly harder than copper, the primary metal known to have been used in Egyptian tools during the Old Kingdom. Experimental archaeology has shown that granite can indeed be worked using copper tools and abrasive sand, but producing surfaces as flat and smooth as those found in the Valley Temple would require enormous time and careful craftsmanship. Some granite blocks within the temple show surfaces that appear almost machine-like in their regularity, leading a few researchers to suggest that ancient craftsmen may have employed techniques that are not yet fully understood, possibly involving advanced abrasive processes or highly specialized stoneworking methods that have left little archaeological evidence behind. Another unresolved issue involves the precision with which the blocks were fitted together. Many of the joints between stones show no evidence of mortar or binding material. Instead, the stones appear to have been carefully shaped so that their surfaces fit together with near-perfect contact, creating structural stability through sheer weight and friction. Achieving this kind of fit requires extremely careful measurement and alignment, yet the tools used for such precise measurement during the Old Kingdom are still a matter of debate. Wooden measuring rods, plumb lines, and leveling instruments are known from later Egyptian contexts, but the exact techniques used to ensure perfect alignment of blocks weighing dozens of tons remain uncertain. Transportation also presents a formidable puzzle, and the granite blocks used in the temple were quarried in Aswan, where archaeologists have identified ancient quarry marks and partially carved blocks that provide insight into Egyptian stone extraction methods. However, moving blocks weighing 40 tons or more over a distance of hundreds of kilometers would have required a complex logistical operation involving river barges, sledges, and large labor forces. Relief carvings from later periods depict the transportation of large statues on sledges pulled by workers over lubricated ground, but scaling this method up to move dozens of massive granite blocks remains a challenge that modern researchers continue to analyze. Finally, there is the question of polishing. The granite surfaces within the temple are not merely cut. They are also polished to a level that reflects light and gives the stone a refined, almost ceremonial appearance. Modern granite polishing typically involves mechanical grinding with increasingly fine abrasives, yet the exact sequence of tools and abrasives used by ancient Egyptian craftsmen is still debated. Some scholars believe that quartz sand combined with stone polishing tools may have produced the effect, while others argue that achieving such uniform polish across massive surfaces would have required techniques far more sophisticated than currently understood. These unresolved questions are what make the Valley Temple of Khafre so fascinating to archaeologists and historians today. While mainstream Egyptology credits its construction to the organized labor and engineering knowledge of Egypt's Old Kingdom, the remarkable precision of its granite masonry still raises debates about the techniques used. Even after decades of research, the complete explanation of how such massive and precise stone architecture was achieved more than 4,000 years ago remains uncertain, leaving the temple as both a monument to Khafre and a lasting mystery of ancient engineering. How do you think the ancient Egyptians were able to cut, transport, and fit these massive granite blocks with such astonishing precision? Share your thoughts or theories in the comments below. Long before modern cartography, before satellites, compasses, and global coordinates, a small clay tablet from ancient Mesopotamia attempted to capture the structure of the entire world. Known today as the Babylonian Imago Mundi map, this artifact is widely considered the oldest surviving map of the world ever discovered. The tablet dates to approximately the 6th century BCE and is currently preserved in the British Museum under catalogue number BM92687. At first glance, it appears almost primitive. A piece of baked clay, roughly 12 by 8 centimeters, inscribed with cuneiform writing and a circular diagram scratched into its surface. Yet behind its modest appearance lies one of the most fascinating puzzles in the history of ancient knowledge. The Imago Mundi is not merely a drawing. It represents an attempt by the Babylonians to organize geography, cosmology, and cultural identity into a single visual model of reality. Even more surprising is the precision with which this miniature artifact appears to encode spatial relationships, precision that raises questions about how such knowledge could have been gathered more than 2,600 years ago. The tablet was first studied in detail in the late 19th century after being acquired by the British Museum during excavations in Mesopotamia. It is believed to have been produced during the Neo-Babylonian period, a time when the city of Babylon was one of the largest urban centers on Earth. Archaeologists suggest that the tablet likely originated from the scholarly libraries of Babylon or nearby Sippar, where scribes preserved astronomical records as mathematical tables and geographic texts. When researchers began translating the cuneiform inscriptions carved across the tablet, they realized they were not looking at a simple map of a city or region. Instead, the diagram attempted to represent the entire known world. At the center sits Babylon itself, depicted as the focal point of the universe. A vertical line passing through the center represents the Euphrates River, the lifeline of Mesopotamian civilization. Around Babylon appear the names of other known territories such as Assyria and Urartu. Encircling everything is a ring labeled the Bitter River, widely interpreted as the ocean that surrounds the world. Beyond that ocean lie mysterious triangular regions known in the text as Nagu, distant lands described as unreachable or mythic. Thus, what makes the Imago Mundi particularly extraordinary, however, is not merely its symbolism but the remarkable spatial organization contained within such a tiny object. The entire world, at least as the Babylonians conceived it, is compressed into an area smaller than a modern smartphone. Despite this limitation, the map manages to encode directional relationships, relative distances, and geographic structure in a way that suggests a surprisingly sophisticated understanding of spatial representation. The Euphrates River runs through the center in roughly the correct orientation. Known territories are placed in relation to Babylon in positions that correspond broadly with their real-world locations. Even the circular boundary representing the ocean appears carefully proportioned. For a culture working with nothing more than clay tablets and reed styluses, the ability to translate geographic knowledge into a coherent visual schema is remarkable. To appreciate the scale of this achievement, it helps to compare the Imago Mundi with other early maps. The famous Greek geographer Anaximander, who lived around the 6th century BCE, also produced a map of the world, but his original work survives only in written descriptions from later authors. The earliest preserved Greek maps appear centuries later and were typically drawn on parchment or papyrus, materials that rarely survive. In contrast, the Babylonian tablet endured precisely because it was made of clay and fired in a kiln. This accident of preservation allows us to see directly how Mesopotamian scholars visualized the world. When compared with medieval European TO maps produced nearly 1,500 years later, the Babylonian tablet reveals striking conceptual similarities. Both traditions represent the world as a circular disk surrounded by water, placing a culturally significant city at the center. Yet the Imago Mundi predates those medieval maps by more than a millennium. The precision of the tablet raises an intriguing question. How did Babylonian scholars gather the geographic information necessary to construct such a map? Mesopotamia possessed no satellites, no magnetic compasses, and no system of longitude and latitude. Nevertheless, the Babylonians were among the most mathematically advanced cultures of the ancient world. Their base 60 numerical system, known as the sexagesimal system, Zuski, is still used today in our measurement of time and angles: 60 seconds in a minute, 60 minutes in an hour, and 360 degrees in a circle. This mathematical tradition allowed Babylonian astronomers to perform complex calculations of planetary motion. It is therefore possible that similar geometric reasoning was applied to geographic representation. Scholars have suggested that Babylonian scribes may have used simple surveying tools, ropes, and angular measurements to estimate directions and distances across the landscape. Trade networks stretching across the Near East would also have supplied travelers' reports describing rivers, mountains, and distant kingdoms. Another remarkable feature of the Imago Mundi is the geometry of its circular ocean boundary. Creating a clean circle on a small clay surface is not trivial. Modern archaeologists studying the tablet have noted that the ring appears relatively even, suggesting it may have been inscribed using a rotational technique or measuring device rather than freehand drawing. Some researchers speculate that ancient scribes could have used a cord anchored at a central point to trace a circle, effectively creating a primitive compass. However, no direct archaeological evidence of such instruments has yet been discovered in Mesopotamian contexts. If such tools existed, they may have been made of wood or other perishable materials that did not survive in the archaeological record. This absence of evidence leaves open the possibility that the Babylonians developed geometric drawing techniques that remain poorly understood. Excavations across Mesopotamia throughout the 20th century have revealed thousands of clay tablets containing astronomical calculations, mathematical problems, and geographic lists. Tablets discovered at sites such as Nippur, Sippar, and Babylon demonstrate that scribal schools trained students in complex numerical and observational methods. These discoveries suggest that the Imago Mundi did not emerge from a vacuum. Instead, it likely represents the visual culmination of centuries of accumulated knowledge. The tablet may even be a simplified copy of a larger map or geographic tradition that has since been lost. If so, the artifact we see today might represent only a fragment of a much broader system of ancient cartography. Yet the tablet is not purely scientific, while the mysterious triangular regions beyond the ocean hint at a cosmological dimension. Some of these areas are described in the accompanying text as distant lands where strange conditions exist, places where the sun cannot be seen, or where travel takes impossible lengths of time. These descriptions blur the boundary between geography and mythology. To the Babylonians, the world was not merely a physical landscape, but part of a larger cosmic order, governed by gods and celestial forces. The Imago Mundi therefore functions simultaneously as a map, a cosmological diagram, and a cultural statement about the centrality of Babylon itself. Modern researchers continue to debate the true purpose of the tablet. Was it a teaching tool used in scribal schools to explain the structure of the world? Was it a symbolic representation of Babylon's political dominance? Or was it an attempt to summarize geographic knowledge gathered through trade and exploration? Each hypothesis explains part of the evidence, yet none fully resolves the mystery. What remains undeniable is the extraordinary intellectual achievement encoded within a piece of clay barely larger than a human hand. Today, more than 2.5 millennia after its creation, the Babylonian Imago Mundi continues to challenge modern assumptions about ancient knowledge. Despite the absence of advanced instruments, Babylonian scholars managed to represent the world as a structured system within a small clay diagram. Its spatial logic, geometric design, and symbolic meaning reveal an intellectual sophistication that still fascinates historians and archaeologists today. How do you think the Babylonians more than 2.5 millennia ago were able to create a world map with such surprising accuracy on a tiny clay tablet? Share your thoughts or theories in the comments below. The Tel Rehov apiary is one of the most astonishing discoveries ever made about agricultural technology in the ancient world. Hidden beneath the soil of the Jordan Valley in modern-day Israel, the remains of this site reveal what may be the oldest large-scale beekeeping installation ever discovered. Dating to the 10th to 9th centuries, BCE, roughly 3,000 years ago, the apiary demonstrates that the people of the Iron Age Levant were operating something that looks remarkably like a controlled honey production industry. The site was uncovered during archaeological excavations led by Professor Amihai Mazar of the Hebrew University of Jerusalem in the early 2000s at the ancient city of Tel Rehov. What archaeologists initially believed to be fragments of pottery turned out to be something far more surprising: rows of cylindrical clay beehives carefully stacked in organized layers. As excavation continued, at least 30 intact hives were revealed, and researchers estimate that the original installation may have contained between 100 and 200 hives. If those numbers are accurate, the apiary could have produced several hundred kilograms of honey annually, an extraordinary figure for a society that existed nearly 3 millennia ago. Each hive was constructed from clay and shaped into a horizontal cylinder approximately 80 centimeters long and about 40 centimeters in diameter. The front of the cylinder had a small opening through which bees could enter and exit, while the rear of the hive was sealed with a removable clay lid. This design allowed ancient beekeepers to harvest honey and beeswax from the back of the hive without destroying the internal comb structure, a technique that resembles principles used in modern beekeeping. However, what makes Tel Rehov truly remarkable is not simply the presence of early beehives, but the engineering logic behind their arrangement. The hives were stacked in rows that resembled walls, sometimes forming multiple layers. This configuration suggests a deliberate attempt to optimize space, increase production, and maintain organized management of dozens, possibly hundreds, of bee colonies at the same time. In other words, Tel Rehov appears less like a small rural apiary and more like a controlled agricultural facility embedded within the urban landscape of an ancient city. Yet the most intriguing and still partially unexplained feature of the Tel Rehov apiary lies in its thermal design. The Jordan Valley is one of the hottest regions in the Near East. Summer temperatures regularly exceed 40 degrees Celsius, and in such conditions bee colonies can easily collapse due to overheating. Modern beekeepers must carefully manage hive placement, ventilation, and shade to prevent excessive heat from destroying a colony. What astonished archaeologists and environmental researchers studying the Tel Rehov hives is that the ancient design seems to have solved this problem with surprising effectiveness. The clay cylinders themselves functioned as natural thermal regulators. Clay has strong thermal inertia, meaning it absorbs heat slowly during the day and releases it gradually as temperatures drop at night. This characteristic helps stabilize internal hive temperatures even in harsh climates. The thickness of the clay walls in the Tel Rehov hives appears to have been intentionally calibrated to maintain a stable internal environment for the bees. The horizontal tubular shape of the hives also contributed to temperature control. Unlike vertical wooden hives common in modern beekeeping, the long cylindrical shape distributes heat along the entire length of the structure. This reduces the likelihood of concentrated hot zones forming within the hive. Furthermore, the stacking arrangement created shaded microenvironments. Hives placed in the lower rows would naturally be shielded from direct sunlight by the layers above them. This layered structure effectively created a passive cooling system similar to architectural strategies used in traditional desert buildings. In many ancient Middle Eastern cities, thick mud brick walls and narrow shaded streets were used to maintain cooler interior temperatures. Tel Rehov's apiary may represent a biological application of the same principle. By arranging the hives in dense rows and using heavy clay insulation, the ancient beekeepers may have engineered a stable thermal environment without any mechanical intervention. Researchers studying the site have attempted to estimate how effective this system might have been. Thus, environmental modelling suggests that clay structures of similar thickness can reduce internal temperature fluctuations by as much as 10 to 15 degrees Celsius compared to external air temperatures. If this estimate is even partially correct, it would mean that when the outside temperature in the Jordan Valley reached 40 degrees Celsius, the interior of the hive might have remained within the safe range required for bee colony survival. This is an extraordinary level of environmental adaptation for a technology that existed nearly 3,000 years ago. Modern industrial beekeeping often relies on artificial ventilation, insulated hive boxes, and precise monitoring of colony conditions. Yet the Tel Rehov system appears to have achieved a similar level of environmental control using nothing more than clay, spatial organization, and passive thermodynamics. Another surprising discovery further complicates the story. Genetic analysis of bee remains found in the Tel Rehov hives indicates that the bees were not native to the local Levantine environment. Instead, the DNA appears to match a subspecies known as the Anatolian honeybee, native to what is now Turkey. This suggests that the inhabitants of Tel Rehov may have deliberately imported bee colonies from hundreds of kilometers away. The distance between Anatolia and the Jordan Valley exceeds 500 kilometers. Transporting living bee colonies across such distances in antiquity would have required remarkable logistical planning. Bees are extremely sensitive to disturbance and temperature change during transportation. Even in the modern world, moving bee colonies require specialized equipment and careful timing. The presence of Anatolian bees in Tel Rehov implies that the ancient inhabitants were not only practicing advanced beekeeping, but may also have been selectively importing bee species known for higher productivity or gentler behavior. Excavations at the site also revealed traces of beeswax, honey residues, and charred hive fragments, indicating that the apiary may have been destroyed by fire at some point in its history. The destruction layer helped preserve the clay structures, allowing archaeologists to reconstruct the layout of the installation. Interestingly, the apiary was located inside the urban area of Tel Rehov rather than in the surrounding countryside. This raises another mystery. Large concentrations of bees can be dangerous, and most traditional beekeeping cultures place apiaries at some distance from residential areas. Yet here the hives were integrated into the city itself. Some scholars speculate that honey production may have been centrally managed or economically significant enough to justify its presence inside the settlement. Honey in the ancient Near East was not merely a food. It served as a sweetener in a world before sugar, a medicinal substance used in treatments and ointments, a fermentable ingredient for beverages such as mead, and an important material for religious offerings. Despite its remarkable sophistication, the technology of the Tel Rehov apiary seems to disappear from the archaeological record after the Iron Age. Similar large-scale clay hive systems have rarely been found elsewhere, leaving historians puzzled. It is possible that the techniques used at Tel Rehov were a unique local innovation that was never widely spread, or that the knowledge was later lost due to political upheaval or environmental changes. Whatever the reason, the site challenges long-held assumptions about ancient technological limits. 3,000 years ago, in one of the hottest regions of the Near East, people had already developed a carefully engineered honey production system, suggesting that ancient agricultural technology may have been far more advanced than we once believed. How were ancient people 3,000 years ago able to design beehives that naturally regulated temperature in the extreme heat of the Jordan Valley? Share your thoughts or theories in the comments below. High above the valley of Bakhchisarai, carved directly into a limestone plateau rising more than 550 meters above sea level, stand the silent remains of Chufut Kale, one of the most enigmatic cave cities of Eastern Europe. From a distance, the plateau appears almost empty, but as visitors approach its cliffs, they begin to notice dark openings scattered across the rock face. These are not natural caves. They are rooms, corridors, storage chambers, stairways, and defensive passages, hundreds of them, cut directly into the mountain itself. Archaeological evidence suggests that the earliest fortifications may date back to the 6th or 7th century, likely established during the frontier period of the Byzantine Empire, although some researchers suspect the plateau may have been used even earlier by steppe cultures moving through Crimea. Over the centuries, the site was occupied by various groups, including the Crimean Tatars and later the Karite community, gradually transforming the plateau into a fortified stone city that relied as much on geology as on architecture for survival. What makes Chufut Kale particularly striking is the sheer scale of its rock-cut engineering. entire neighborhoods were carved into limestone walls with remarkable precision. Many chambers have flat ceilings, straight vertical walls, and rectangular doorways that appear almost geometric in their symmetry. Some rooms contain carved shelves, storage niches, and internal partitions, while others are connected through narrow staircases that descend deeper into the cliff. Archaeologists studying the tool marks have concluded that the builders likely used iron chisels and hammers, yet the smoothness and consistency of some surfaces raise questions about how such large volumes of stone were removed with relatively simple tools. The site contains hundreds of excavated rooms, suggesting an enormous amount of labour and coordination over generations. Comparable rock-cut settlements exist in places like Cappadocia, where entire underground cities were carved from volcanic tuff. But Chufut Kale differs in that many of its structures cling to exposed cliff faces rather than hiding beneath the ground. This design created both habitation and defence simultaneously. Defence was in fact one of the plateau's greatest advantages. The city occupies a narrow tabletop ridge with cliffs dropping more than 100 metres on three sides. Only one practical approach exists, and it winds upward through a narrow valley before reaching the fortress gates. Medieval engineers enhanced this natural barrier with thick stone walls and angled gateways designed to slow attackers. The main access road climbs in sharp turns, forcing anyone approaching the city to expose their flank to defenders above. Similar defensive strategies appear in other ancient fortresses such as Masada in Israel, where steep cliffs protected the settlement from invasion. Yet Chufut Kale's fortifications reveal a more complex combination of built structures and natural terrain, essentially turning the entire plateau into a single defensive machine. However, the most fascinating mystery of Chufut Kale is not its fortifications or its carved dwellings, it is water. A fortress perched hundreds of meters above the surrounding valley should not be able to sustain a large population for long, especially during a siege. There are no natural springs on the plateau, and rainfall in the region is irregular. Yet archaeological excavations have revealed that the inhabitants developed a surprisingly advanced system for capturing and storing water directly within the rock. This system is one of the most intriguing engineering features of the site and remains only partially understood today. Across the plateau, researchers have identified multiple large cisterns carved deep into the limestone bedrock. Some of these reservoirs measure several meters across and could hold tens to hundreds of cubic meters of water. Channels cut into the stone surface appear to have directed rainwater toward these storage chambers, allowing the city to collect every possible drop during seasonal storms. Similar rain harvesting systems existed in other ancient settlements, such as the Nabatean city of Petra, where elaborate channels and reservoirs captured water from flash floods in the desert. But Petra lies within a canyon system with access to groundwater and seasonal flows. Chufut Kale, by contrast, sits isolated on an exposed plateau, making its water management far more difficult. The engineering challenge becomes even more puzzling when the geology of the plateau is considered. Limestone is porous and often allows water to seep through cracks over time. For a reservoir carved directly into limestone to function effectively, it must somehow be sealed or treated to prevent leakage. Archaeologists examining the cistern walls have found traces of coatings that may have acted as waterproof layers, possibly composed of lime plaster or other mineral mixtures. Yet the precise composition and application methods remain uncertain. Some cistern surfaces appear polished or smoothed in ways that suggest deliberate preparation before sealing. Others contain stepped interiors that may have helped stabilize water levels or facilitate maintenance. Despite decades of research, scholars still debate how effective these waterproofing techniques were and how often the reservoirs needed to be repaired. and evidence from excavations conducted in the 20th century and later Ukrainian archaeological surveys suggests that the water storage network may have been large enough to sustain the city for extended periods. Based on estimates of population size and reservoir capacity, some researchers propose that Chufut Kale could survive sieges lasting several months. This would place it among the more sophisticated water management systems of medieval fortresses. For comparison, the defenders of Masada relied on massive cisterns that could store tens of thousands of cubic meters of water, while Byzantine fortresses across Anatolia often depended on hidden springs or aqueducts. Chufut Kale appears to have relied almost entirely on rainwater harvesting and storage, a strategy that required careful planning of every roof surface, courtyard, and drainage channel across the settlement. Another remarkable discovery came in 1998, when archaeologists uncovered what is now known as the Siege Well, a deep shaft cut into the plateau's rock. The well descends approximately 45 to 50 meters, with carved steps spiraling downward through the limestone. If fully functional, it may have allowed access to groundwater deep beneath the plateau, providing an additional emergency water source. Excavating such a shaft with medieval tools would have been a formidable task. Workers would have needed to remove tons of rock from a confined vertical space while maintaining structural stability. The presence of this well suggests that the inhabitants of Chufut Kale understood the vulnerability of their water supply and attempted to create multiple layers of redundancy within their system. Nearby archaeological zones also include the vast Karit Cemetery, containing thousands of stone tombstones dating from roughly the 13th to the 18th centuries. These inscriptions provide evidence of a long-lasting community that lived on the plateau even after political control of the region shifted repeatedly. Yet despite centuries of habitation, the city was gradually abandoned during the 19th century as residents moved into the surrounding valleys. What remains today is a landscape of carved stone, silent chambers, and weathered fortification walls overlooking the Crimean hills. For modern researchers, Chufut Kale remains both a historical monument and an engineering mystery. Its vast rock-cut architecture reveals generations of labour, but the most intriguing puzzle is its water system. Capturing and storing water on such an exposed mountain required technical knowledge that is still not fully understood. Compared with ancient systems at Petra or Masada, Chufut Kale appears to have turned an entire mountain into a self-contained survival structure. Even today, the efficiency of its reservoirs, the waterproofing materials, and the excavation methods used in solid rock remain subjects of ongoing research. What engineering secret do you think allowed the ancient inhabitants of Chufut Kale to build and maintain a water system on top of a mountain for centuries? Share your thoughts in the comments below. Rising from a limestone plateau overlooking the valleys of southwestern Crimea, the ancient cave settlement known as Eski Kerman Cave City appears at first glance like a natural cliff formation. But a closer look reveals something far more extraordinary. Hidden within the rock face are hundreds of precisely carved chambers, corridors, stairways, and sanctuaries. Archaeologists estimate that more than 340 artificial caves were cut directly into the limestone plateau, forming an entire city sculpted from solid rock. The site is believed to have emerged around the 6th century during the frontier expansion of the Byzantine Empire, when fortified settlements were established to defend trade routes and agricultural valleys. Yet even with this historical context, the scale and technical execution of Eski Kerman remain deeply puzzling. Unlike ordinary rock shelters created by erosion, nearly every chamber here bears clear signs of deliberate engineering. Walls appear remarkably flat, ceilings curve smoothly, and corners often meet at angles so consistent that some researchers have compared the interiors to spaces shaped with modern stone-cutting tools. The most striking mystery of Eski Kerman lies in the creation of its immense network of caves. More than 300 rooms are distributed across several levels of the plateau, connected by stairways and narrow passages carved directly into the stone. Some chambers are small, domestic spaces barely large enough for a family, while others are spacious halls used for storage or gatherings. Archaeologists studying the site have identified caves used as homes, wine cellars, granaries, chapels, and defensive galleries. In many cases, the rock floors include carved troughs, shelves, and benches that were formed from the same block of stone as the surrounding walls. This means the builders did not assemble structures piece by piece. They sculpted entire rooms from a single mass of limestone. To carve such spaces would have required enormous labour. Experiments conducted by archaeologists suggest that even with iron chisels, removing a single cubic metre of limestone by hand could take many days of work. Considering that some of the larger caves at Eski Kerman measure several metres in height and depth, the creation of hundreds of such chambers would represent thousands of hours of continuous stone cutting. The scale becomes even more impressive when compared with other cave cities of the region. Sites such as Mangup Kale Cave Fortress or Chufut Kale Cave City also feature rock-cut architecture, yet Eski Kerman stands out for the density and organisation of its caves. Many of the chambers are aligned along narrow terraces that follow the contour of the plateau, suggesting a carefully planned urban layout rather than random excavation. In some areas, the caves appear stacked vertically, creating a multi-level structure similar to an apartment complex carved into stone. This raises a key question. How did the builders maintain such consistent geometry without modern measuring instruments? Archaeologists studying tool marks have identified patterns consistent with iron chisels and picks. But the precision of many surfaces suggests that the workers followed strict construction methods, possibly guided by wooden templates or cords used as measuring lines. The mystery deepens when examining the defensive design of the caves. Eski Kerman was not simply a collection of dwellings. It functioned as a fortified settlement controlling the surrounding valleys. The plateau itself rises roughly 300 metres above the surrounding landscape, with steep cliffs forming natural walls on most sides. Only a few narrow paths allow access to the summit. Along these routes, archaeologists have found caves carved specifically for defence, including chambers with narrow openings that resemble arrow slits. From inside these spaces, defenders could observe approaching enemies while remaining protected by thick layers of stone. Some vertical shafts appear to have been used to drop stones or boiling liquids onto attackers attempting to climb the slopes. The integration of architecture and terrain suggests a sophisticated understanding of military strategy, comparable in concept to later medieval fortresses. Archaeological research at Eski Kerman began in earnest during the 19th century, when explorers first documented the caves and mapped the plateau. More systematic excavations were conducted in the 20th century by Soviet archaeologists, who uncovered fragments of pottery, metal tools, and religious objects within the chambers. These discoveries confirmed that the caves were inhabited for several centuries, likely from the 6th through the 13th century. The evidence of churches carved into the rock further indicates the presence of a Christian community connected to Byzantine cultural traditions. In one cave chapel, faint traces of frescoes were discovered on the walls, suggesting that the stone interior once served as a decorated place of worship. The presence of such religious spaces reinforces the idea that Eski Kerman was not merely a military outpost, but a fully developed town. Another remarkable aspect of the cave system is the presence of water infrastructure carved directly into the rock. On a plateau where natural springs are scarce, the survival of a permanent settlement would have depended on careful water management. Archaeologists have identified reservoirs and channels designed to collect rainwater and direct it into storage basins. One of the larger cisterns is estimated to have held tens of thousands of litres of water. The floors of these basins were carved with subtle slopes to ensure that water flowed toward collection points rather than stagnating. Such engineering suggests that the builders possessed practical knowledge of hydraulic principles, even if their techniques were developed through experience rather than formal science. Yet despite decades of research, the greatest question remains the same. How was such a vast network of caves created with the technology available at the time? Iron chisels and hammers could certainly cut limestone, but producing hundreds of chambers with relatively smooth walls would have required extraordinary coordination and labour. Some researchers believe that the work may have been carried out gradually over generations, with each new family expanding the caves as the population grew. Others argue that at least part of the complex must have been excavated during a concentrated construction phase directed by a centralized authority. The truth may lie somewhere between these possibilities, but definitive evidence remains elusive. The final mystery surrounding Eski Kerman concerns its sudden decline. Archaeological evidence suggests that the settlement was abandoned sometime in the 13th century, possibly during the wave of destruction associated with the Mongol invasions of Europe. However, some artifacts indicate that parts of the city may have been deserted even earlier. The caves that once housed families, stored harvests, and echoed with daily life gradually fell silent, leaving behind an empty labyrinth carved into the cliffs. Today, the plateau stands as a silent monument to a society capable of shaping an entire city from living rock. The hundreds of caves of Eski Kerman remain a powerful reminder that ancient communities often possess technical skills far more advanced than we assume. Even after centuries of study, the question still lingers among archaeologists and historians alike. What methods, organization, and determination allowed the builders of this forgotten city to transform a barren limestone plateau into one of the most remarkable cave settlements ever created? How were ancient builders able to carve more than 300 caves into the rock cliffs of Eski Kerman Cave City with such remarkable precision using only primitive tools? What techniques do you think they used? Share your thoughts in the comments below. Hidden beneath the coastal soils of northern Syria, in the ruins of the ancient city of Ugarit, archaeologists uncovered a collection of clay tablets that would profoundly reshape our understanding of ancient writing and literacy. These artifacts, now known as the Ugaritic Baal cycle tablets, were first discovered in 1928 when a local farmer accidentally exposed a tomb while ploughing near the archaeological mound of Ras Shamra. French archaeologist Claude Schaeffer soon began systematic excavations at the site, and over the following years his team uncovered an entire archive of clay tablets dating to the late Bronze Age, roughly the 14th to 12th centuries before the Common Era. Among these texts was a remarkable mythological narrative now referred to as the Baal cycle, a series of tablets describing the epic struggles of the storm god Baal against rival divine forces such as the sea god Yam and the death god Mot. Yet while the mythological story itself fascinated historians, what truly astonished scholars was not only the narrative content but the extraordinary technological precision embedded in the tablets themselves, particularly the remarkable accuracy of their engraved writing. Unlike most ancient Near Eastern scripts, the writing on the Baal cycle tablets uses the Ugaritic alphabet, a unique system composed of roughly 30 distinct characters arranged in a cuneiform style. This alone was surprising because most earlier cuneiform systems from regions such as Mesopotamia required hundreds of symbols to represent syllables or whole words. The Ugaritic system, by contrast, functioned much more like a true alphabet, representing individual sounds rather than entire syllables. Linguists have long debated how such a streamlined alphabetic structure emerged so early in history. But an equally compelling mystery lies in the physical execution of the writing itself. When researchers examined the Baal cycle tablets under magnification, they noticed something unusual. The wedge-shaped impressions forming each letter were strikingly consistent in depth, angle, and spacing. On many tablets, the triangular impressions appear nearly identical from one line to the next, suggesting a level of scribble precision rarely seen in Bronze Age clay writing. Archaeological studies of several tablets, particularly those catalogued as KTU 1.1 through KTU 1.6, the principal fragments of the Baal cycle, revealed that the characters are arranged in carefully aligned horizontal rows with minimal deviation. Measurements of some tablets show that line spacing varies by only fractions of a millimeter, across surfaces more than 20 centimeters wide. For comparison, many Mesopotamian administrative tablets from similar periods display irregular spacing, uneven wedges, and visible corrections where scribes pressed the stylus too deeply into the clay. The Baal cycle tablets, however, often show no such corrections. Each symbol appears deliberate and controlled, as though the scribe followed a precise visual template. This has led some researchers to speculate that Ugaritic scribes may have been trained in a formal scribal school, where writing techniques were standardized. Another intriguing aspect of the engraving precision involves the writing tools themselves. Traditional cuneiform writing was typically performed with a stylus made from a cut reed. The triangular shape of the stylus tip produced wedge-shaped marks when pressed into soft clay. However, microscopic analysis of several Baal cycle tablets suggests that the wedges sometimes possess unusually sharp edges and consistent angles, raising questions about whether the scribes might have used specially crafted tools rather than simple reed stems. Some scholars have proposed that the styluses could have been carefully trimmed to standardize shapes, allowing scribes to produce uniform impressions. Others suggest the possibility that multiple stylus types were used to achieve different wedge sizes, enabling scribes to control the geometry of the scripts more precisely. The production process of the tablets themselves may also have contributed to the accuracy of the inscriptions. Archaeologists examining clay samples from Ugarit found that the tablets were often made from finely filtered local clay with very small particle sizes, producing a smooth surface ideal for writing. Some tablets appear to have been partially dried before being inscribed, allowing the stylus to create sharper wedge edges without deforming the surrounding clay. Once inscribed, many of the tablets were likely baked or hardened by accidental fires during the destruction of the city around 1180 before the Common Era. Ironically, the catastrophic burning of Ugarit, possibly linked to invasions associated with the Sea Peoples, may have preserved the tablets by firing them into durable ceramic objects capable of surviving more than 3 millennia. Excavations throughout the 20th century uncovered thousands of tablets in multiple archives across Ugarit, including temple libraries and administrative buildings. Among them were literary texts, diplomatic correspondence, economic records, and ritual instructions. Yet the Baal cycle tablets remain among the most studied because of their narrative complexity and extraordinary scribal craftsmanship. Several tablets show evidence that the scribes carefully planned the layout before writing, leaving margins at the edges and spacing lines evenly across the surface. In some fragments, a faint guide impressions appear beneath the final wedges, suggesting that scribes may have lightly marked the clay before carving the final text. If true, this would indicate a surprisingly methodical writing process, something more reminiscent of manuscript preparation than simple clay inscription. The precision of the Baal cycle tablets has therefore become a focal point in discussions about ancient scribal technology. Bronze Age scribes worked without magnification, metal engraving tools, or mechanical guides, yet they produced writing that appears remarkably standardized. When compared with contemporary inscriptions from other civilizations, the tablets of Ugarit often appear unusually neat and deliberate. Even the orientation of the wedges tends to remain consistent throughout entire texts, Yet such uniformity suggests not only technical skill, but also a highly developed scribal tradition in which training, materials and tools were carefully controlled. Today, the Baal cycle tablets are regarded as one of the most important discoveries for understanding the intellectual world of the ancient Levant. They reveal a culture capable of producing sophisticated literature, developing an early alphabetic script, and preserving complex mythological narratives about divine power and cosmic order. Yet at the same time, they raise enduring questions about the technologies and methods used to produce them. How did Bronze Age scribes achieve such extraordinary consistency in their inscriptions? Were their tools more advanced than previously believed, or were their training systems far more rigorous than historians once imagined? More than 3,000 years after the fall of Ugarit, the delicate wedges impressed into these clay tablets still challenge modern scholars, reminding us that the technological capabilities of ancient civilizations may have been far more refined than the fragments of history alone might suggest. How do you think Bronze Age scribes were able to carve the Baal cycle tablets with such near-perfect precision? Share your thoughts in the comments below. Hidden beneath the limestone hills of northern Israel lies one of the most remarkable underground burial complexes ever discovered in the ancient world, the Beit Shearim catacombs. Located near the ancient city of Beit Shearim, this vast subterranean necropolis dates primarily to the 2nd through 4th centuries CE and is widely associated with the burial place of Judah Hanasi, a towering figure in Jewish history. The catacombs first attracted modern archaeological attention in 1936, when excavations led by the Israeli archaeologist Benjamin Mazar began to reveal a labyrinth of chambers carved deep into the bedrock. What initially appeared to be a modest burial cave soon proved to be only the entrance to an immense underground complex. Over the decades that followed, archaeologists uncovered more than 30 catacomb systems spread across the hillside, containing hundreds of burial chambers and an extraordinary collection of stone sarcophagi. The sheer scale of the underground network alone is impressive, but what truly fascinates historians and archaeologists is the astonishing craftsmanship displayed in the stone coffins found inside these chambers. These sarcophagi represent some of the most sophisticated examples of funerary stone carving from the late Roman world. Many of them were carved from heavy blocks of limestone that could weigh several tons, yet their surfaces display an extraordinary level of precision and artistic detail. Decorative motifs include lions, eagles, mythological creatures, elaborate floral patterns, geometric borders, and religious symbols such as the 7-branch menorah. In some cases, entire architectural facades appear carved into the coffin lids, with columns, pediments, and miniature temple fronts sculpted directly from the stone. The level of craftsmanship rivals that seen in high-status Roman sarcophagi found in cities like Rome or Antioch. Yet here these works were produced in a remote hillside necropolis, far from the major imperial centers of the Mediterranean. Researchers examining these carvings have noted that many of the decorative elements display near-perfect symmetry, with balanced proportions and deeply cut lines that remain sharp even after nearly 2,000 years. Some of the ornamental grooves are only a few millimeters wide, yet extend across long surfaces without deviation, and is suggesting that the artisans possessed remarkable control over their tools. The technical challenge becomes even more striking when considering the environment in which these coffins were produced and installed. The catacombs themselves were carved directly into solid limestone beneath the surface of the hill. Narrow corridors lead to larger halls where dozens of sarcophagi are arranged side by side. Some of the largest chambers measure more than 10 meters across and contain massive stone coffins aligned in rows along the walls. Moving such heavy objects into confined underground spaces would have required careful planning, specialized labor, and coordinated effort. Yet there is little direct archaeological evidence describing the methods used to transport and position these massive stones. And yet, unlike surface tombs where cranes or large ramps might have been employed, the underground environment of Beit Shearim would have severely limited the use of large lifting equipment. This raises a fascinating question. Were the sarcophagi carved outside the catacombs and then carried inside, or were some of them shaped within the chambers themselves after the blocks had been lowered into the caves? Both possibilities present significant logistical challenges that researchers are still attempting to understand. Archaeological excavations carried out throughout the 20th century gradually revealed the extraordinary diversity of these sarcophagi. During major excavation campaigns in the 1950s and 1960s, researchers documented hundreds of coffins across multiple catacomb complexes. Some are simple rectangular boxes, while others display elaborate sculptural programs covering every visible surface. One particularly famous chamber, often referred to as the Hall of the Coffins, contains more than 40 decorated sarcophagi arranged around the perimeter of a large underground hall. Many of them carry inscriptions written in Greek, Hebrew, or Aramaic, indicating that the individuals buried there came from communities across the Mediterranean world. Scholars have identified names associated with cities as distant as Palmyra, Tyre, and even regions of southern Arabia. This suggests that Beit Shearim became an internationally recognized burial site within the Jewish diaspora, attracting individuals who wished to be interred in what was considered sacred ground. Transporting bodies across such distances during antiquity was already a complex process, but transporting heavy stone sarcophagi for burial within these caves would have been an even greater logistical undertaking. The precision of the carvings has also led researchers to examine the tools used by the ancient craftsmen. Traditional iron chisels and hammer stones were certainly available in the Roman period, yet the clean lines and consistent depth seen in many carvings indicate a level of technical mastery that required both experience and specialized technique. Some grooves appear so regular that they almost resemble the results of guided cutting tools. When compared with other funerary carvings from the same era, such as the stone sarcophagi of Roman Syria or Asia Minor, the Beit Shearim examples stand out for their distinctive fusion of cultural motifs. Classical Greco-Roman imagery appears alongside clearly Jewish symbols, reflecting the multicultural environment of the Eastern Mediterranean during the late Roman period. This blending of artistic traditions further suggests that highly skilled artisans were working within the site, perhaps travelling craftsmen who specialised in funerary sculpture. Yet no workshop areas have been clearly identified within the catacombs themselves, leaving open the possibility that many coffins were carved elsewhere before being transported into the caves. Beyond the artistry of the sarcophagi, the engineering of the catacomb complex itself adds another layer of mystery. The underground passages were carved through solid limestone using manual tools, as yet the corridors often run remarkably straight and connect multiple chambers with careful geometric alignment. Some rooms contain vaulted ceilings that appear intentionally shaped to prevent collapse, demonstrating a clear understanding of structural stability within underground spaces. The creation of such a large and coherent subterranean complex would have required careful planning long before the first chisel struck the rock. However, the methods used by ancient engineers to map and coordinate excavation beneath the hillside remain uncertain. Without modern surveying equipment or artificial lighting systems, maintaining straight corridors and symmetrical chamber layouts deep underground would have been extremely difficult. Oil lamps discovered in the catacombs provide evidence of illumination, but their dim light would have made detailed stone carving particularly challenging. Today, the Beit Shearim catacombs are recognized as one of the most important archaeological sites in Israel and a UNESCO World Heritage Site. Yet despite decades of research, many questions remain. The massive stone sarcophagi, intricately carved and placed deep within the underground chambers, still puzzle researchers. How were multi-ton coffins transported through narrow corridors without damaging their delicate carvings? And why did people from across the ancient Mediterranean choose this remote hillside for burial? Even today, the catacombs continue to reveal how much about ancient engineering and craftsmanship remains unknown. Could the extremely intricate carvings on the stone sarcophagi inside Beit Shearim catacombs really have been created using only ancient hand tools? Or did ancient craftsmen possess techniques that we still do not fully understand? Share your thoughts in the comments below. Rising like a blade of dark stone above the forests of western India, the steep rock staircase of Calivant Durg is one of the most unsettling examples of ancient mountain engineering ever carved by human hands. Located in the rugged Sahyadri range near Prabalgad Fort in the state of Maharashtra, the structure consists of a narrow series of stone steps cut directly into the side of a near-vertical basalt pinnacle that rises approximately 686 meters above sea level. Seen from a distance, the staircase appears almost impossible, an exposed ribbon of steps spiraling up a volcanic cliff with sheer drops on both sides. There are no railings, no protective walls, and in many sections the width of the steps measures barely 20 to 30 centimeters, just enough space for a single foot. Even modern hikers equipped with climbing gear often describe the ascent as terrifying. Yet the staircase itself may date back at least 6 centuries, possibly to the period of the Ahmednagar Sultanate in the 15th century. What makes Calivant extraordinary is not merely the dramatic location, but the technical question of how such a structure was ever constructed. And perhaps even more puzzling, why? The geological setting itself adds to the mystery. The mountain belongs to the Deccan Traps, one of the largest volcanic basalt formations on Earth, created by massive lava flows around 65 million years ago. Basalt is an extremely hard igneous rock, resistant to erosion and notoriously difficult to carve using primitive tools. The archaeologists who have studied ancient quarry sites across the Deccan Plateau note that shaping basalt typically requires heavy iron chisels, repeated hammering, and long labor periods. Yet the steps at Calivant Durg show signs of deliberate shaping, flattened surfaces, consistent spacing in several segments, and carefully carved footholds designed to follow the natural layering of the volcanic rock. Some of these steps remain remarkably intact despite centuries of monsoon rains, temperature fluctuations, and natural erosion. When compared with other rock-cut stairways in India, such as those at Daulatabad Fort or the cliff paths leading to the caves of Ajanta Caves, Calivant appears far more precarious and exposed. Those sites incorporate defensive walls, tunnels, or protected corridors. Calivant does not. Instead, it climbs the naked face of a volcanic spire. One of the biggest technical questions concerns the method of construction. If workers carved the staircase from the bottom upward, they would have needed to stand on extremely narrow footholds while chiseling directly into vertical rock, all while suspended above enormous drops. If they carved it from the top downward, the process would have required ropes or scaffolding anchored into the cliff. Yet surprisingly few clear anchor holes remain visible today. Some researchers have suggested that temporary wooden scaffolding may have been used, but wood leaves little archaeological trace after centuries of exposure. Others propose that the staircase was gradually extended as climbers created new footholds while descending with ropes. Similar techniques have been documented among Himalayan cliff builders who carved monasteries into rock walls, but the scale and steepness of Calivant still raise doubts about how safe or practical such a process would have been using medieval technology. However, the most intriguing mystery is not the engineering but the purpose. Why would anyone construct such an extreme staircase in the first place? Historians studying the region have long associated Calivant Durg with nearby Prabalgad Fort. which served as a strategic stronghold controlling trade routes between the Konkan coast and the Deccan Plateau. During the medieval period, this corridor carried caravans transporting salt, spices, and textiles inland. From the summit of Calavantin, the view extends across the surrounding valleys and passes, suggesting the possibility that the pinnacle functioned as an observation tower or lookout point. In theory, guards stationed at the top could signal approaching armies or monitor movement across the landscape, yet this explanation remains incomplete. Unlike many defensive hill forts of the Deccan, the summit of Calavantin shows little evidence of substantial fortifications. Archaeological surveys conducted during the late 20th century by regional historians documented scattered stone foundations and water cisterns carved into the rock, but no large barracks, temples, or defensive walls comparable to those found at Prabalgad itself. This absence of clear structural remains has fueled ongoing debate among archaeologists and historians. Some researchers argue that Calavantin may have served a ceremonial or symbolic function rather than a purely military one. In several ancient cultures across South Asia, mountain summits were regarded as sacred spaces associated with gods, spirits, or cosmic symbolism. The act of climbing a difficult path could represent a ritual journey or spiritual test. Comparable examples exist at sites like the rock fortress of Sigiriya in Sri Lanka, where monumental stairways lead visitors up sheer rock faces to reach a royal palace complex. Yet Sigiriya's staircases were designed with elaborate guardrails and terraces, indicating careful planning for frequent use. Calavantin's staircase, by contrast, seems almost intentionally dangerous, suggesting it was not intended for large numbers of visitors. Another possibility proposed by local historians involves signalling and communication networks between hill forts. Throughout the Deccan region, medieval rulers maintained chains of forts positioned on mountain peaks so that signals, often smoke by day or fire by night, could be transmitted rapidly across long distances. If Calavantin served as one node in such a network, its extreme elevation would have offered a commanding vantage point. Still, even this explanation raises questions. Why carve such a hazardous staircase instead of building a more accessible path along the ridge? Some scholars believe the dangerous design may itself have been a defensive strategy. An invading army would struggle to climb such narrow steps under attack from defenders above. In this sense, the staircase might have functioned less as a route of convenience and more as a deliberately difficult access point. The debate remains unresolved because direct historical documentation is scarce. Unlike many famous forts of India, Calavantin appears rarely in surviving written records from the medieval Deccan. Oral traditions from nearby villages claim that the pinnacle was named after a queen called Calavantin, though historians have found little archival evidence to confirm the story. Archaeological exploration has also been limited by the difficulty of reaching the summit safely with equipment. Surveys conducted in the early 2000s recorded several carved water reservoirs and traces of habitation, suggesting that people did spend time on the peak, but the scale of occupation remains uncertain. Without extensive excavation, it is difficult to determine whether the summit once supported wooden structures that have since vanished. The steps of Calivant Durg are astonishing, not only because they were carved into hard basalt on a near-vertical cliff, but also because their true purpose remains unknown. Was this once a military lookout, a ritual path, or part of an ancient signalling system? While many mountain stairways lead to temples or fortresses, the steps at Calavantin seem to lead only to an unsolved mystery. For archaeologists, the biggest question is not how they were built, but why people in the past wanted to reach the top of such a dangerous peak in the first place. What do you think the true purpose of this staircase was? A military outpost, a ritual pathway, or a secret lost to history? Share your thoughts in the comments below. Deep in the far northeastern corner of Niger, In one of the most isolated and unforgiving landscapes on Earth lies the Jado Plateau, a vast sandstone massif rising from the endless dunes of the Sahara. Today the plateau is silent, surrounded by wind-carved cliffs and seas of shifting sand. Yet scattered across its rocky ridges stand the haunting remains of abandoned rock cities and fortified settlements, constructed centuries ago by people whose technological abilities still puzzle archaeologists. Known collectively as the Jado Plateau rock cities, these ruins include the fortress settlement of Jado itself, along with nearby sites such as Segadim and other smaller stone villages built directly into the desert plateau. To modern researchers, the most astonishing aspect of these cities is not merely their location in an environment that appears almost impossible for sustained human settlement, but the unexpected sophistication of their stone fortress architecture, which demonstrates a level of engineering precision that seems surprisingly advanced for such an isolated region. The Jado Plateau lies roughly 800 kilometers northeast of the Nigerian city of Agadez, and only a few hundred kilometers from the borders of Libya and Chad. This region receives almost no rainfall, and summer temperatures frequently exceed 45 degrees Celsius. Despite these extreme conditions, archaeological surveys conducted during the 20th century revealed the remains of large stone compounds, defensive towers, multi-level houses, and massive perimeter walls constructed from carefully shaped sandstone blocks. These structures were not randomly assembled shelters, but organized defensive cities, positioned strategically on elevated ridges and cliff edges where they commanded wide views across the surrounding desert. The main fortress at Jado itself stands on a rocky outcrop overlooking a dry valley, its walls and towers forming a defensive complex that appears strikingly similar in concept to medieval desert citadels found in North Africa or the Middle East. The architectural techniques visible at Jado have become one of the most intriguing aspects of the site. The builders quarried local sandstone and shaped it into relatively uniform blocks, stacking them in carefully aligned courses to create walls that could reach several meters in height. In many places, the stones are fitted together with remarkable precision, using only minimal binding material. Even after centuries of desert wind erosion, the walls remain standing, demonstrating a structural stability comparable to ancient stone fortifications found in regions with far greater technological resources. Archaeologists have noted that some structures contain internal staircases carved directly into the stone walls, along with narrow passageways designed to control movement within the fortress. This type of design suggests a sophisticated understanding of defensive architecture, similar in principle to fortified settlements seen in other ancient trade centres along trans-Saharan routes. Early documentation of the Jado ruins was carried out by European explorers in the early 20th century, but systematic archaeological attention increased later in the century as researchers began to recognise the significance of the site. Surveys conducted by French and Nigerian expeditions documented dozens of stone buildings arranged in clustered defensive patterns, with walls sometimes exceeding 2 meters in thickness. The layout of these structures indicates deliberate planning rather than organic growth. Houses were often built tightly together inside protective walls, creating a compact urban core that could be defended from external attack. Defensive towers positioned along the outer walls would have allowed guards to monitor approaching travellers or potential raiders across the desert landscape. Such features suggest that the inhabitants expected conflict or competition, and are perhaps linked to the control of valuable trade routes that once crossed this region of the Sahara. What continues to puzzle researchers is how the builders of Jado achieved such construction in an environment with limited resources and minimal archaeological evidence of advanced tools. Few metal implements have been discovered at the site, and the surrounding desert lacks large timber supplies that might have been used for scaffolding or lifting mechanisms. Yet the placement of heavy stone blocks in elevated fortifications implies the existence of coordinated labour and organised construction methods. Some walls appear to have been erected on steep cliff edges, requiring careful alignment and stabilisation. Comparisons have occasionally been made to other desert fortresses, such as the Sar settlements of Morocco or ancient Saharan caravan cities, but Jado's extreme isolation makes such parallels difficult to confirm. The plateau lies far from the main medieval trade centres that might have transmitted architectural knowledge, raising the possibility that the builders developed their techniques locally. Another fascinating aspect of Jado's architecture is the way its builders integrated natural rock formations into their defensive design. Instead of constructing walls across open ground, many of the structures were anchored directly into the sandstone cliffs of the plateau. Natural ridges were extended with stone masonry to create continuous defensive barriers. In some places, entire sections of buildings appear to be carved partially from the rock itself, blending constructed walls with the geological structure of the plateau. This approach greatly increased the fortress's defensive strength, while reducing the amount of building material required. Such techniques show a deep understanding of the local terrain and an ability to adapt architecture to environmental constraints. Archaeological investigations have also revealed extensive cemeteries surrounding the Jado settlements, consisting of hundreds of stone-marked graves. These burial sites indicate that the plateau supported a relatively stable population for a significant period of time. However, the identities of the inhabitants remain uncertain. Some scholars suggest connections to early Saharan peoples or trans-Saharan trading communities, while others believe the settlements may have been linked to nomadic groups who periodically occupied fortified bases along caravan routes. The scarcity of written records means that much of Jado's history must be reconstructed solely through architectural remains and limited material artifacts. Equally mysterious is the eventual abandonment of the Jado cities. At some point, likely several centuries ago, the settlements were gradually deserted. Today only empty stone towers and eroded walls remain, standing like silent sentinels above the desert sands. Environmental change may have played a role, as shifting trade routes and increasing desertification could have made the region less viable for long-term habitation. Yet the fortresses themselves remain astonishingly intact, preserving evidence of a society capable of organising complex construction projects in one of the harshest environments on the planet. For modern archaeologists and historians, the Jado Plateau rock cities represent a striking reminder that advanced architectural knowledge was not limited to the great empires traditionally emphasized in history. Hidden deep within the Sahara, these forgotten fortresses demonstrate a level of engineering skill that challenges assumptions about technological development in remote desert societies. The precision of the stonework, the strategic placement of defensive structures, and the integration of architecture with natural rock formations all point to a culture that possessed both practical engineering knowledge and a sophisticated understanding of military architecture. Yet despite decades of exploration, many questions remain unanswered. Who exactly built these cities? What tools and techniques did they use to shape and position their sandstone blocks with such precision? And how did a community capable of constructing such formidable fortresses ultimately vanish from the plateau, leaving behind only ruins slowly eroding under the relentless winds of the Sahara? Who do you think actually built the mysterious stone cities on the Jado Plateau? And what kind of technology might they have used to construct such precise sandstone fortresses in the middle of the harsh Sahara Desert? Share your thoughts in the comments below. Deep in the mountains of southern Colombia, within the misty highlands surrounding the upper Magdalena River Valley, lies one of the most mysterious archaeological landscapes in the Americas, the stone statues of San Agustin Archaeological Park. Scattered across hills, burial mounds, and ancient ceremonial platforms are more than 500 monumental sculptures carved directly from massive blocks of volcanic rock. Some statues stand barely a metre tall, while others rise more than 7 metres above the ground and weigh several tons. These enigmatic figures, often depicting human forms combined with jaguars, birds, serpents, or other powerful animals, were created by a civilization that flourished roughly between the 1st century BCE and the 8th century CE. Yet despite more than a century of research, archaeologists still do not know exactly who these people were, what language they spoke, or why they disappeared. Among all the mysteries surrounding San Agustin, one of the most astonishing, and still debated, is the extraordinary stone carving technology used to produce these sculptures from some of the hardest volcanic rocks in the region. The majority of the statues were carved from andesite and basalt, 2 dense volcanic stones formed from ancient lava flows in the Andes. On the Mohs hardness scale, basalt and andesite can approach values around 6 or higher, making them significantly more difficult to carve than softer stones, such as limestone or sandstone, which were commonly used in many ancient civilizations. For comparison, the builders of the Great Pyramid of Giza primarily shaped limestone blocks, while even many classical Greek sculptures were carved from relatively workable marble. At San Agustin, however, ancient artisans were shaping extremely resistant volcanic rock with a precision that continues to surprise modern researchers. Detailed examination of the statues reveals sharp incised lines, symmetrical facial features, deep recessed eyes, and carefully sculpted teeth and claws. In many cases, the surfaces appear deliberately flattened and polished, suggesting a controlled and systematic carving process rather than simple rough shaping. Archaeological investigations into these sculptures began in earnest in the early 20th century. In 1913, the German ethnologist Konrad Theodor Preuss conducted one of the first scientific expeditions to document the monuments. Preuss mapped dozens of statues and burial mounds and was astonished by the level of craftsmanship visible in the stonework. Later excavations throughout the 1930s and 1940s revealed that many statues were positioned above elaborate tombs constructed from large stone slabs. Beneath these mounds, archaeologists discovered burial chambers containing ceramics, gold ornaments, and ritual offerings, suggesting that the statues served as guardians or symbolic protectors of the dead. Yet the technical question remained unresolved. How did a society without known metal tools capable of cutting hard volcanic rock produce such refined sculptures? One theory proposes that artisans used extremely hard hammerstones made from quartzite or similar materials to slowly chip away at the surface. Experiments conducted by modern archaeologists attempting to replicate the technique have shown that shaping volcanic rock with stone tools is possible, but extremely labor-intensive. In some experimental reconstructions, creating even a small, detailed figure required hundreds of hours of continuous work. Scaling this effort to the monumental statues of San Agustin, some weighing several tons, would imply an enormous investment of labor and highly specialized craftsmanship. Yet despite extensive excavations across the region, relatively few stone tools directly associated with the sculpting process have been found, leaving many scholars uncertain about the exact techniques employed. Another intriguing detail lies in the consistency of the statue's iconography and proportions. Many figures display strikingly symmetrical facial structures, evenly spaced eyes, and carefully balanced compositions. In certain sculptures, the depth of carved grooves and the angles of the lines remain remarkably uniform across the entire monument. Such precision suggests that the sculptors may have used guiding techniques, perhaps charcoal sketches, string measurements, or geometric planning, before carving the stone. Comparable levels of geometric planning are seen in the polygonal masonry of Sacsayhuaman, where Inca builders achieved extraordinary stone-fitting precision. However, unlike the Inca structures, the San Agustin statues are not merely structural blocks, but complex three-dimensional sculptures with intricate symbolic features. Equally puzzling is the apparent quarrying and transportation process. Geological studies indicate that many statues were carved from local volcanic outcrops, yet some appear to have been moved from quarries located several kilometers away. Transporting multi-ton stone blocks through steep Andean terrain covered with dense vegetation would have required coordinated manpower and possibly wooden rollers or sledges. Yet no clear evidence of large-scale transport infrastructure has been discovered. Similar mysteries surround other megalithic sites across the world, such as the massive stones of Baalbek, where ancient builders moved enormous blocks without technologies that historians would normally associate with such engineering feats. Beyond their technical sophistication, the statues themselves present an iconographic mystery. Many depict beings with exaggerated fangs, wide circular eyes, and animal attributes, often associated with the jaguar, one of the most powerful symbols in ancient American cosmology. Some statues appear to show figures holding severed heads or ceremonial staffs, while others combine human bodies with bird or reptilian features. Scholars believe these images may represent mythological guardians, priests, or deities connected to the afterlife. Their placement near burial chambers reinforces the interpretation that they played a role in funerary rituals or spiritual protection. Despite decades of excavation, however, the civilization responsible for these sculptures remains largely unknown. Radiocarbon dating of associated organic materials suggests that the statues were created over a period spanning several centuries, roughly between the 1st century BCE and the 8th century CE. By the time Spanish explorers entered the region in the 16th century, the culture that built the monuments had long disappeared. No written language or historical record survives to explain their beliefs, their social organization, or the precise methods they used to carve their remarkable monuments. Today, San Agustin is recognized as one of the most important archaeological sites in South America and has been designated a World Heritage Site by UNESCO. Yet even with modern archaeological techniques, satellite mapping, and geological analysis, many aspects of the statues remain unresolved. The extraordinary craftsmanship visible in these sculptures, carved from some of the hardest volcanic stones in the Andes, continues to challenge assumptions about the technological capabilities of ancient societies in the region. Standing silently across the Colombian highlands, the statues of San Agustin seem less like simple monuments and more like enduring messages from a lost civilization, carved into stone so hard that their creators clearly intended them to survive for millennia. In your opinion, how could an ancient civilization precisely carve extremely hard volcanic rock like the statues at San Agustin thousands of years ago? Share your thoughts or theories in the comments below. Rising above the rocky landscape of southern Malta, the ruins of the Borg in-Nadur temple stand as one of the most intriguing remnants of the island's prehistoric civilization. Built roughly between 2500 and 2000 BCE, during the late phase of Malta's remarkable megalithic temple culture, the site represents the final chapter of a tradition that had already produced some of the oldest monumental stone structures on Earth. Long before the pyramids of Egypt reached their final form and centuries before the great trilithons of Stonehenge were erected, the people of Malta were already shaping enormous blocks of limestone into temples of surprising precision. Yet despite more than a century of archaeological investigation, beginning with the first scientific excavations carried out in the early 20th century, and continuing with later surveys and studies by Maltese and international researchers, the technological methods used to construct Borg in-Nadur remain only partially understood. Among all the mysteries of the site, none is more striking than the massive megalithic stones themselves, colossal blocks of local limestone that were cut, transported and positioned with a level of control that still challenges modern explanations. The walls of the temple complex are formed from stones that in many cases measure 3 to 4 meters in length and weigh between 10 and 20 tons. All these blocks were not casually piled together but carefully aligned to create stable architectural forms that have endured for more than 4,000 years despite earthquakes, erosion, and human disturbance. Even today, some of the surviving stones stand upright with remarkable balance, fitted closely enough that large gaps are rare despite the complete absence of mortar. This dry stone precision is particularly striking when compared with other ancient building traditions. For example, the earliest faces of Göbekli Tepe in southeastern Turkey also used large stones, yet many of those pillars were carved directly from bedrock and erected nearby. At Borg in-Nadur, however, the stones appear to have been quarried and then transported across uneven terrain before being raised into place. On a small island with limited forests and no evidence for large draft animals during this period, such operations would have required an extraordinary level of planning and communal labour. Archaeologists estimate that moving a single 10-ton block using primitive technology could require dozens of workers coordinating ropes, wooden sledges, rollers, and possibly lubricated pathways of wet clay or water-soaked soil. Yet even with these hypothetical methods, the precise positioning of the stones, often standing vertically and supporting heavy horizontal slabs, remains difficult to reconstruct in detail. Excavations conducted at the site in 1922 and later expanded in the 1950s revealed that the temple followed the characteristic Maltese megalithic layout, as with curved chambers or apses arranged around a central axis. Within these structures, archaeologists uncovered fragments of pottery, animal bones, and traces of ritual activity that suggested the building served a ceremonial or religious function during the final centuries of the island's temple-building era. But the architectural focus of Borg in-Nadur appears to have been its structural walls themselves. The megalithic blocks were carefully chosen from local Globigerina limestone, a relatively soft stone when freshly quarried, but one that hardens over time when exposed to air. Even so, shaping blocks of this scale using stone tools and early copper implements would have required enormous patience and skill. Tool marks visible on some stones indicate that prehistoric masons repeatedly chipped and smoothed surfaces to achieve stable contact points between blocks. The result is a form of prehistoric engineering in which stability depends entirely on geometry and gravity rather than adhesives or binding materials. Comparisons with other Maltese temples emphasize how impressive this achievement truly was. Sites such as Hagar Kim and Menajdra display similarly massive stones, some weighing more than 20 tons, yet Borg in-Nadur belongs to a later phase in which construction methods were beginning to change. In addition to the temple itself, the site also features an enormous surrounding wall that stretches for roughly 200 meters and reaches several meters in thickness in certain sections. This wall, built from many of the same massive stones, suggests the complex may have served not only as a ritual center, but also as a fortified settlement during the early Bronze Age. The existence of such a defensive structure is unusual among Maltese temple sites, and has led some researchers to speculate that social conditions on the island were becoming increasingly unstable at the time. If conflicts or migrations were occurring, the ability to construct large protective walls from multi-ton blocks would have required coordinated engineering knowledge and a substantial labor force. Despite these clues, the full technological story behind Borg in-Nadur remains elusive. No surviving written records describe the people who built it. and the prehistoric culture responsible for Malta's megalithic temples appears to have declined or disappeared around 2500 BCE. Archaeological layers suggest that later, Bronze Age communities reused parts of the site, leaving behind domestic artifacts that differ from the earlier ritual materials. Yet even these later inhabitants did not fully replicate the extraordinary megalithic construction techniques of their predecessors. The temple stones therefore stand as silent evidence of a lost tradition of building knowledge, one that emerged on a small Mediterranean island thousands of years ago and then faded into mystery. Modern archaeologists continue to analyze quarry marks, transport routes, and architectural alignments in an effort to understand how such immense stones could have been manipulated with Neolithic tools and human muscle alone. For now, however, Borg in-Nadur remains one of the most compelling examples of prehistoric engineering, a place where enormous megaliths were raised with astonishing accuracy, leaving behind a puzzle that still challenges both archaeologists and engineers in the present day. In your opinion, how did prehistoric people manage to transport and erect the massive multi-ton stones at Borg in-Nadur using only primitive tools? Share your thoughts in the comments below. In the remote lava fields and sandstone deserts of northwestern Saudi Arabia, archaeologists have identified one of the most puzzling monumental landscapes ever discovered in the prehistoric world: the mustatil ritual structures. These long rectangular stone enclosures, some stretching more than 600 meters in length, dot the arid terrain around Alula and neighboring regions in remarkable numbers. First recognized in large scale through satellite imagery and aerial survey in the early 21st century, these structures initially appeared as faint geometric outlines against the desert floor. What followed was a wave of archaeological investigation that revealed not just isolated monuments, but a vast ritual landscape constructed roughly 7,000 to 9,000 years ago during the Neolithic period. Today, their researchers have identified more than 1,600 mustatil structures across northwestern Saudi Arabia, making them one of the largest concentrations of prehistoric ceremonial architecture known anywhere on Earth. Their age is particularly striking. Radiocarbon dating of organic material recovered from excavations conducted between 2018 and 2021 suggests that many mustatils were built around 5,000 to 6,000 BCE, thousands of years before the pyramids of Egypt and centuries before Stonehenge began to take shape in Britain. Yet what truly sets these monuments apart is not only their antiquity or their sheer scale, but the sophisticated construction techniques employed to build them in one of the harshest environments imaginable. At first glance, the mustatil appears deceptively simple, a long narrow rectangle formed by two parallel stone walls connected by massive end platforms or chambers. But closer inspection reveals an engineering challenge far greater than it initially seems. Many of these structures extend hundreds of meters across uneven terrain composed of volcanic basalt flows and shifting desert sediments. Despite this difficult landscape, the walls of the mustatil maintain a remarkably straight alignment. Archaeological measurements conducted during surveys led by the Royal Commission for Alula and international research teams show that the parallel walls often deviate by only a few degrees across distances that can exceed half a kilometer. Achieving this level of geometric precision without modern surveying equipment raises profound questions about the technical knowledge possessed by the Neolithic communities who constructed them. The walls themselves are typically between 1 and 1.5 meters high and composed of carefully stacked stones, often basalt or sandstone collected from the surrounding terrain. Crucially, the builders used what is known as dry stone construction, placing rocks without mortar or binding material. This technique requires careful balancing and interlocking of stones to ensure stability, especially in environments subject to strong desert winds and extreme temperature fluctuations. Constructing such structures in a desert environment would have presented enormous logistical challenges. Temperatures in northwestern Saudi Arabia frequently exceed 40 degrees Celsius during the summer months, and water sources are scarce. Yet the mustatils were built using thousands of stones, some weighing several hundred kilograms. Even conservative estimates suggest that a single large mustatil may contain tens of thousands of individual rocks. Transporting and arranging these stones would have required coordinated labor by large groups of people. For comparison, the effort involved in building a 400-meter mustatil wall could rival the stone transport required for early phases of megalithic monuments in Europe. However, unlike Stonehenge, where the largest stones were dragged from quarries dozens of kilometers away, mustatil builders appear to have used locally available materials. Even so, collecting, carrying, and precisely placing these stones across hundreds of meters would have required significant organization. Some researchers estimate that constructing a large mustatil may have required hundreds of workers operating over several weeks or even months. This level of coordinated labor implies a degree of social complexity among Neolithic pastoral communities that archaeologists had not previously associated with prehistoric Arabia. The technical challenge was not only the transportation of stones, but also maintaining structural stability in shifting desert conditions. Dry stone architecture is inherently vulnerable to collapse if the stones are not arranged with careful attention to weight distribution. Modern dry stone walls in rural Europe rely on carefully shaped stones and centuries of accumulated building knowledge. Yet the mustatil walls demonstrate similar stability despite being built nearly 8 millennia ago. In many cases, the walls remain standing today, surviving thousands of years of erosion, seasonal flooding, and temperature extremes. Some structures appear partially buried by sand drifts, while others sit exposed on basalt plateaus, yet the underlying geometry remains visible from the air. This durability suggests that the builders possessed a practical understanding of structural engineering principles such as load distribution and wall batter, the slight inward tilt used to stabilize dry stone walls. While such knowledge could have developed through experience, the scale and consistency of the mustatils imply that these techniques were widely shared among communities across the region. Another remarkable aspect of the mustatil structures is their placement within the landscape. Many are located on elevated plateaus or near ancient water sources, suggesting that builders deliberately selected locations that were both visible and symbolically significant. Geological studies indicate that during the early Holocene period, when the mustatils were built, the Arabian Peninsula experienced a much wetter climate than today. This era, sometimes referred to as the Green Arabia period, saw the formation of lakes, grasslands, and seasonal rivers across areas that are now barren desert. In this environment, pastoral communities likely raised cattle, sheep, and goats across wide grazing territories. Archaeological excavations carried out in 2019 and 2020 revealed a critical clue about the function of these structures. Inside one mustatil's terminal chamber, researchers discovered a deposit containing the skulls and horns of cattle, along with bones from goats and sheep. Radiocarbon dating of these remains confirmed their Neolithic age. The arrangement of the bones suggested deliberate placement, possibly as offerings. This discovery led archaeologists to interpret the mustatils as ceremonial monuments associated with ritual gatherings and animal sacrifice. However, the architecture of the mustatils raises further questions about their purpose. Unlike large temples or communal spaces found in later civilizations, the interior corridors of the mustatils are extremely narrow, often only a few meters wide. This design would have made it difficult for large groups of people to gather inside simultaneously. Instead, Some archaeologists propose that the structures functioned as processional pathways, where participants may have walked along the long corridor toward the terminal chamber where rituals were conducted. If this interpretation is correct, the extraordinary length of some mustatils, reaching up to 600 meters, may have been intended to create a dramatic ceremonial journey culminating at the altar area. In that sense, the architecture may have been designed not merely for practical use, but for symbolic impact, emphasizing distance, movement, and ritual progression. Similar concepts appear in later monumental architecture such as Egyptian temple avenues or the long causeways leading to Mesoamerican pyramids. Yet the mustatils predate those traditions by thousands of years. The scale of the mustatil phenomenon also suggests a cultural network that extended across large portions of northwestern Arabia. The discovery of more than 1,600 structures distributed across an area hundreds of kilometers wide indicates that multiple communities participated in building them over several centuries. This widespread distribution raises the possibility that the mustatils represented a shared religious system among early pastoral societies. In this sense, the construction of these monuments may have served not only a ceremonial function, but also a social one, bringing together dispersed groups to participate in collective rituals. Such gatherings could have reinforced alliances, established seasonal meeting points, or coordinated the movement of herds across grazing territories. Yet despite these theories, many questions remain unanswered. No permanent settlements associated directly with the mustatils have been identified nearby, and very few everyday artifacts such as tools or pottery have been found within the structures themselves. This absence suggests that the monuments were not used for habitation or routine activities, but rather for specific ritual events. From a technological perspective, the mustatil structures challenge long-standing assumptions about the capabilities of Neolithic societies in Arabia. For decades, archaeologists believed that the region's prehistoric populations consisted primarily of small, mobile pastoral groups with limited capacity for large-scale construction. The discovery of the mustatils forces a re-evaluation of that view. Coordinating the labor required to build thousands of large stone monuments implies a level of organization and cultural cohesion far beyond what was previously imagined. Even more puzzling is the sudden disappearance of the tradition. After several centuries of construction activity, the building of mustatils appears to have stopped. As the climate became increasingly arid and desert conditions intensified, the pastoral cultures that built these monuments may have dispersed or transformed into different social systems. Without written records, the identity of the builders and the full meaning of their rituals remain unknown. Today, the mustatil structures remain as silent traces across the Saudi desert, or visible from satellite images yet still not fully understood. Their long stone walls mark places where ancient communities once gathered for rituals now lost to history. Built with simple tools and coordinated labor thousands of years ago, they reveal remarkable human ingenuity. Yet the greatest mystery remains not how they were built, but why they were built at all. So what do you think the true purpose of these massive mustatil structures was? Share your thoughts in the comments below. Hidden beneath the quiet landscape of southern Spain, within the ancient megalithic complex of Antequera, lies one of the most puzzling architectural features ever discovered inside a prehistoric monument. Known today as the Cueva de Menga, this enormous dolmen was built around the late Neolithic period, roughly between 3,800 and 3,600 BCE. Archaeologists have long admired the structure for its colossal scale. The chamber stretches approximately 27.5 meters in length, supported by massive stone pillars and capped by enormous limestone slabs, some estimated to weigh more than 150 tons. These stones are among the largest ever used in any megalithic monument in Europe, see rivaling the engineering ambitions seen in sites such as Stonehenge in Britain or the Great Passage Tomb of Newgrange in Ireland. Yet despite the impressive scale of its architecture, the most astonishing and least understood feature of the monument lies not in the stones above ground, but deep below the floor of the chamber itself. Near the end of the interior corridor, archaeologists discovered a perfectly vertical shaft descending more than 19 meters into the bedrock beneath the dolmen. This well-like structure, carved directly into the natural limestone, remains one of the most enigmatic engineering achievements of prehistoric Europe. The existence of this shaft was first documented during early archaeological investigations of the monument in the 19th century, but it was only during systematic excavations in the 20th century that its true depth and structure became clear. Later surveys, including detailed archaeological studies conducted between the 1980s and the early 21st century, as part of the broader research on the Antequera dolmen site, confirmed that the shaft measures approximately 19.5 meters deep, with a diameter of roughly 1.5 meters. The walls of the shaft appear surprisingly regular and vertical, suggesting deliberate and careful excavation rather than a natural fissure or collapse. What makes this discovery particularly puzzling is the technological context in which it was created. When the builders of Cueva de Menga constructed their monument more than 5,500 years ago, and metallurgy was still in its earlier stages in the Iberian Peninsula. Most tools available to Neolithic communities consisted of stone, bone, and occasionally simple copper implements. Yet even with modern steel tools, excavating a shaft nearly 20 meters deep through compact limestone would require considerable effort and planning. The question therefore arises, how did a prehistoric community manage to dig such a deep, vertical shaft inside a completed stone monument? The engineering challenge becomes even more extraordinary when one considers the confined environment in which the excavation must have taken place. Unlike mining shafts carved into open hillsides, the Menga shaft lies inside an enclosed chamber whose roof is formed by enormous stone slabs weighing dozens of tons. These stones would have already been positioned before the shaft was completed, meaning that the workers excavating the well were operating within a dark, narrow interior space with limited ventilation. Removing the excavated stone and soil from such a depth would have required a coordinated system for lifting debris upward through the shaft and transporting it along the corridor to the outside. No physical traces of ropes, wooden lifting frames, or pulley systems have survived, but the sheer volume of material removed suggests that some form of mechanical assistance must have been used. Estimates based on the dimensions of the shaft indicate that more than 40 cubic meters of limestone and sediment may have been extracted, representing many tens of tons of material that had to be transported out of the monument. Another layer of mystery concerns the original purpose of this extraordinary feature. One hypothesis proposed by archaeologists suggests that the shaft functioned as a water well. Indeed, water is still present at the bottom of the shaft today, and hydrogeological studies indicate that it intersects a natural groundwater level beneath the dolmen. If the builders intentionally dug the shaft to access water, it would represent one of the earliest known examples of deep groundwater extraction in prehistoric Europe. However, this interpretation raises further questions. Unlike settlements where wells are essential for daily survival, Cueva de Menga appears to have been primarily a ceremonial or funerary monument rather than a permanent habitation site. Excavations conducted throughout the 20th century uncovered human remains and ritual deposits within the chamber, suggesting that the dolmen served as a collective burial place or sacred structure for the surrounding community. If the monument was indeed used mainly for ritual purposes, why would its builders invest such enormous labor into excavating a well more than 19 meters deep inside the sacred chamber itself? some researchers have proposed that the shaft may have held symbolic or ritual significance rather than a purely practical function. In many ancient cultures, deep shafts, caves, and wells were seen as portals connecting the world of the living with the underworld beneath the earth. The vertical descent of the Menga shaft may therefore have carried cosmological meaning, representing a physical link between the monumental architecture of the dolmen above and the hidden realm below. This interpretation gains additional intrigue when considering the unusual orientation of the monument. Unlike most European megalithic tombs, which are aligned toward the rising sun, the corridor of Cueva de Menga points toward a distinctive natural landmark known as Peña de los Enamorados, a massive rock formation resembling the profile of a human face lying on its back. Some scholars believe that the dolmen, the mountain, and the underground shaft together formed part of a symbolic landscape in which natural and constructed features were integrated into a complex ritual system. Comparisons with other megalithic sites further highlight how unusual the Menga shaft truly is. Across Europe, thousands of dolmens and passage tombs have been documented from the Atlantic coast of Portugal to the plains of Scandinavia. Many of these monuments display impressive engineering, including massive capstones and carefully aligned corridors. However, almost none contain a deep vertical shaft excavated into the bedrock within the chamber itself. Even at sites famous for their elaborate underground passages, such as Newgrange or the megalithic tombs of Brittany, no feature comparable to the 19-metre shaft of Menga has been identified. This uniqueness has led several researchers to argue that the shaft may represent a specialised local tradition or an experimental engineering project undertaken by the prehistoric builders. The construction of the dolmen itself already demonstrates extraordinary logistical capabilities. Archaeological studies estimate that the larger stones used in the monument weigh between 150 and 180 tons, making them among the heaviest stones ever moved by Neolithic communities in Europe. Transporting such massive blocks would have required sophisticated planning, including the use of wooden sledges, rollers, and coordinated labour by large groups of workers. When these achievements are considered alongside the excavation of the deep shaft, it becomes clear that the builders of Cueva de Menga possessed a remarkable understanding of engineering and organisation for their time. Yet despite decades of archaeological investigation, including excavations conducted throughout the 20th century and modern surveys associated with the UNESCO designation of the Antequera Dolmen site in 2016, the precise methods used to create the shaft remain unknown. Today, visitors standing inside the stone chamber of Cueva de Menga can look down into the dark vertical shaft descending deep into the earth. Although it appears simple, it remains one of the great mysteries of prehistoric archaeology. More than 5,700 years after it was carved into the bedrock, researchers still do not know whether it once served as a water well, a ritual passage to the underworld, or a structure whose true purpose has been lost to history. What is certain is that this deep shaft suggests the engineering abilities of Neolithic people may have been far more advanced than we once believed. What do you think the more than 19-metre deep shaft inside Cueva de Menga was really built for? A water source, a ritual gateway, or something even more mysterious? Share your thoughts in the comments below. Near the high plains of the Bolivian Andes, not far from the famous archaeological centre of Tiwanaku, a controversial stone artifact known as the Pocotia monolith has become the subject of intense debate among researchers, archaeologists, and historians of ancient technology. At first glance, the monolith appears similar to other monumental sculptures associated with the Tiwanaku civilization, a powerful Andean culture that flourished roughly between the 5th and the 10th centuries CE near the southern shores of Lake Titicaca. Like the famous Bennett monolith discovered at Tiwanaku in 1932, the Pocotia statue depicts a standing anthropomorphic figure carved from a single block of stone, its body covered with intricate geometric patterns and symbolic motifs. Yet unlike most known Tiwanaku sculptures, the Pocotia monolith displays a series of unusual carved symbols that some researchers believe resemble a form of writing. These mysterious markings, combined with the extraordinary precision of the stone carving itself, have made the artifact one of the most intriguing and controversial objects connected to ancient Andean culture. The story of the monolith's discovery adds another layer to the mystery. The statue reportedly surfaced in the late 20th century in the region surrounding the small Bolivian village of Pocotia, located several dozen kilometers from the main Tiwanaku ceremonial complex. Local accounts suggest that the stone had been partially buried for centuries before being uncovered, although the exact archaeological context was never carefully documented. Because the artifact was not recovered during a controlled excavation led by professional archaeologists, its precise original location and stratigraphic layer remain uncertain. This lack of context has led some scholars to question whether the statue was originally part of a ceremonial complex related to Tiwanaku, or whether it may have been moved or altered at some point in its history. Despite these uncertainties, stylistic comparisons with other Tiwanaku monoliths strongly suggest that the sculpture belongs to the broad artistic tradition of that civilization. The Tiwanaku culture is well known for its monumental stone architecture and sculptural achievements, including enormous carved blocks used in structures such as the Akapana Pyramid, the Kalasasaya Temple Complex, and the precisely cut andesite stones of the Pumapunku platform. Many of these stones weigh between 10 and 100 tons, demonstrating that Tiwanaku engineers possessed highly developed knowledge of quarrying, transport, and stone shaping long before the rise of the Inca Empire. What makes the Pocotia monolith particularly controversial, however, is the apparent complexity of the carving technique used to create its surface details. The statue itself is carved from sandstone, a material commonly found in the region, but still relatively difficult to shape with primitive tools when intricate details are required. Close inspection of the carved patterns reveals deep grooves and sharply defined angles that appear remarkably consistent in depth and spacing. In several sections of the statue, the engraved lines maintain a uniform width of only a few millimeters while extending across large portions of the sculpture's torso. Such precision raises important questions about the methods used by ancient craftsmen to achieve these results. Archaeological studies of Tiwanaku toolkits suggest that stoneworkers in the region primarily relied on hammerstones, chisels made from copper or copper alloys, and abrasive sand used for grinding and polishing surfaces. Copper tools, however, are significantly softer than the sandstone being carved, which means they would normally wear down quickly when used for detailed engraving. Experimental archaeology has demonstrated that carving straight, evenly spaced grooves into sandstone with copper implements requires repeated grinding and polishing rather than simple cutting. This process can produce smooth surfaces, but typically leaves irregular edges and tool marks that differ from the sharp incisions visible on the Pocotia monolith. The contrast becomes even more striking when the statue is compared to other well-documented Tiwanaku sculptures. The Bennett monolith, for example, stands over 7 meters tall and was carved from a single block of andesite, an even harder volcanic rock. While the Bennett statue displays beautifully executed geometric motifs, most of its decorative elements are carved in relatively shallow relief rather than deeply incised lines. Similarly, the famous Gateway of the Sun at Tiwanaku features intricate symbolic figures carved into a massive andesite slab weighing approximately 10 tons. Yet the designs there rely heavily on surface relief rather than narrow engraved channels. The Pocotia monolith appears to combine both techniques, featuring relief elements alongside deeply cut linear markings that some observers claim resemble glyphs or characters arranged in deliberate sequences. If these markings were indeed produced during the original creation of the statue, they would imply an unexpectedly advanced level of stone carving control. Another important comparison comes from the stonework of Puma Punku, a nearby architectural complex often cited as one of the most technically sophisticated construction sites of the ancient Andes. Excavations conducted in the 1970s and later during the early 21st century revealed that many of the stones used in Puma Punku were cut with extraordinary precision, including right angles approaching 90 degrees and flat surfaces that fit together with minimal gaps. Some blocks feature drilled holes and internal channels that appear to have been created using a combination of hammering, abrasion, and possibly rotational drilling with stone tools. Archaeologists studying these structures have demonstrated through experiments that such precision can indeed be achieved using traditional techniques. But the process is extremely labor-intensive and requires highly skilled craftsmanship. When these findings are considered alongside the detailed engraving visible on the Pocotia monolith, they suggest that Tiwanaku stoneworkers may have possessed a level of technical expertise that modern observers often underestimate. Despite these possibilities, the engraved symbols on the statue remain one of its most puzzling aspects. The Tiwanaku civilization is generally believed to have relied on visual iconography rather than a true written language. Unlike the later Maya civilization in Mesoamerica, which developed a complex hieroglyphic script, Andean cultures are thought to have recorded information primarily through oral traditions and devices such as the quipu, knotted cords used by the Inca centuries later for administrative record keeping. These symbols on the Pocotia monolith do not clearly match any known Andean symbolic system. Some researchers have proposed that they might represent a ceremonial code, such as astronomical markers, or a stylized form of proto-writing used for ritual purposes. Others remain skeptical, arguing that the patterns could simply be decorative elements, misinterpreted as text. The debate intensified after several independent researchers attempted to analyze the glyph-like figures in the early 2000s, claiming to identify repeating patterns that might correspond to linguistic structures. However, without additional artifacts displaying similar inscriptions, such interpretations remain speculative. The uncertainty surrounding the monolith's discovery context has further complicated attempts to interpret its meaning. Because the statue was not recovered through a carefully documented excavation, archaeologists cannot definitively determine whether it once stood within a temple courtyard, served as part of a ceremonial gateway, or marked a burial or astronomical alignment site. Radiocarbon dating cannot be applied directly to the stone itself, so scholars rely primarily on stylistic comparisons with other Tiwanaku artifacts to estimate its age. Most researchers place it somewhere between the 6th and 10th centuries CE, the period during which Tiwanaku reached its peak influence across large portions of the central Andes. During this time, the civilization controlled extensive trade networks connecting the high-altitude Altiplano Plateau with regions as distant as northern Chile and southern Peru. Such networks would have enabled the movement of skilled artisans and specialized knowledge across vast distances, potentially explaining how advanced stone carving techniques spread within the culture. Ultimately, the Pocotia monolith highlights the remarkable stoneworking abilities of ancient Andean societies linked to Tiwanaku. Its precise carvings, mysterious symbols, and uncertain discovery continue to puzzle researchers. When compared with the advanced stonework of Puma Punku, the same question remains. How did craftsmen more than 1,000 years ago achieve such precision using simple tools? The Pocotia monolith therefore remains one of the most intriguing mysteries of ancient Andean technology. What do you think about the mystery of the Pocotia monolith? Do you believe the Tiwanaku people truly possessed more advanced stone carving technology than we assume? Or could there be an ancient method that has been lost to history? Share your thoughts in the comments below. Hidden within the quiet plains of northwestern Bulgaria lies one of the most puzzling artifacts of prehistoric Europe, the Gradesnitza tablets, small pieces of clay that may represent one of the earliest symbolic communication systems ever discovered. These mysterious tablets were unearthed in the 1960s during archaeological excavations near the village of Gradesnitza in the Vratsa region, a site associated with a Neolithic settlement dating to roughly 5,000 to 4,500 years before Christ. At first glance, the artifacts appear simple: flat pieces of baked clay marked with geometric lines, crosses, triangles, and unusual abstract symbols. Yet the moment archaeologists began studying them more closely, it became clear that these markings were far from random decoration. The symbols appear carefully organized, etched with deliberate spacing and repeated patterns that strongly suggest intentional meaning. This realization sparked decades of debate among archaeologists, linguists, and historians who now view the tablets as part of a much larger puzzle surrounding the earliest attempts at written communication in human history. What makes the Gradesnitza tablets particularly intriguing is their potential connection to the Vinča culture, a prehistoric civilization that flourished across the Balkans between roughly 5,300 and 4,500 years before Christ. Archaeologists studying artifacts from Serbia, Romania, and Bulgaria have identified hundreds of similar symbols carved into pottery, figurines, and clay tablets. Collectively, these markings are sometimes referred to as the Vinča symbols, and some researchers argue they may represent a form of proto-writing, a symbolic communication system that predates fully developed writing. If this interpretation is correct, the Gradesnitza tablets could be nearly 2,000 years older than the earlier Sumerian cuneiform tablets of Mesopotamia, which are generally dated to around 3,300 years before Christ. Such a possibility challenges long-held assumptions that writing first emerged in the ancient cities of Mesopotamia. Instead, it raises the provocative idea that complex symbolic communication systems may have developed independently in Neolithic Europe. The craftsmanship of the tablets themselves also raises fascinating questions about prehistoric technology. The symbols are carved with surprising precision, forming lines that remain remarkably consistent in depth and spacing. This suggests that whoever created them used a specialized tool, possibly a sharpened bone stylus, a finely shaped stone point, or another instrument capable of producing clean incisions in soft clay. After the symbols were engraved, the tablets appear to have been intentionally fired in heat, hardening the clay and preserving the markings for thousands of years. Such a process indicates a deliberate understanding of ceramic technology. Neolithic communities across southeastern Europe were already skilled potters, but producing durable tablets specifically designed to preserve symbolic information implies a sophisticated cultural purpose. These were not casual decorations on pottery, they were objects meant to last. The context in which the tablets were discovered adds another layer to the mystery. Archaeological excavations at the Gradesnitza settlement revealed remains of houses, pottery fragments, and various ritual objects typical of Neolithic Balkan communities. The tablets were not found randomly scattered, but appear to have been associated with a particular cultural layer within the settlement. Similar symbolic objects have also been discovered in nearby regions, including the famous Tartaria tablets of Romania, which were uncovered in 1961 and contain several symbols strikingly similar to those found at Gradesnitza. These Romanian tablets, sometimes dated to around 5,300 years before Christ, intensified the debate surrounding the possibility of a widespread symbolic tradition in prehistoric southeastern Europe. Some researchers believe these artifacts collectively represent a shared system of symbolic communication used across multiple settlements of the Vinča cultural sphere. Yet despite decades of analysis, the most important question remains unanswered. What were these tablets actually used for? The true function of the Gradesnitza tablets remains one of the most perplexing mysteries in European archaeology. Several competing theories have been proposed, each attempting to explain why Neolithic people would invest time and effort into creating such carefully inscribed objects. One widely discussed hypothesis suggests the tablets may have served ritual or religious purposes. In many early societies, these symbols were closely connected to spiritual beliefs, representing deities, cosmological ideas, or sacred narratives. The arrangement of symbols on the tablets could therefore represent ritual formulas, sacred messages, or symbolic invocations used in ceremonies. Another theory proposes a more practical function. The tablets may have been used as a record-keeping system. In ancient Mesopotamia, clay tokens and tablets were used to track agricultural goods, livestock, and trade transactions long before fully developed writing appeared. Some archaeologists speculate that the Gradesnitza symbols could represent quantities, ownership marks, or administrative information within a Neolithic settlement economy. However, unlike Mesopotamian accounting tablets, the Gradesnitza symbols do not obviously correspond to numbers or commodities, making this interpretation difficult to confirm. A third hypothesis suggests that the tablets may have functioned as an early calendar or astronomical record. Many prehistoric cultures tracked seasonal cycles, lunar phases, and agricultural rhythms through symbolic markings. Some researchers have examined the patterns of symbols on the tablets and proposed that they might encode information about seasonal changes, ritual festivals, or agricultural timing. While intriguing, this idea remains speculative because the available evidence is limited. What complicates matters further is the extremely small number of tablets discovered. Archaeologists have only recovered a handful of examples, and each tablet contains only a short sequence of symbols. Unlike the thousands of cuneiform tablets found in Mesopotamia or the extensive inscriptions of ancient Egypt, the Gradesnitza artifacts provide only fragments of a possible system. Without a large body of text, decipherment becomes nearly impossible. Scholars face the same problem encountered with other undeciphered ancient scripts. Without bilingual inscriptions or long text to analyze, it is nearly impossible to determine whether the symbols represent language, religious symbolism, or something entirely different. The disappearance of the culture that created the tablets adds yet another dimension to the mystery. The Neolithic societies of the Balkan region eventually declined and transformed as new cultures spread across Europe during the Copper Age and Bronze Age. If the Gradesnitza symbols were part of a communication system, it appears that the knowledge of how to interpret them vanished, along with the communities that created them. Unlike later writing traditions that evolved and spread, this symbolic system may have simply disappeared from history. Today, the Gradesnitza tablets remain one of the most mysterious artifacts of prehistoric Europe. Preserved in museum collections, their strange symbols still resist interpretation despite decades of research. Are they traces of a lost writing system, sacred ritual objects, or simple records from a Neolithic community? The truth remains hidden within the silent marks carved into clay more than 7,000 years ago. Until new discoveries appear, perhaps another tablet or a larger inscription, the true purpose of the Gradesnitza tablets will likely remain one of archaeology's enduring mysteries. What do you think the symbols on the Gradesnitza tablets actually represent? An ancient writing system, a religious ritual, or a mysterious message we still cannot understand? Share your thoughts in the comments below.